make any effect in other parts of the change because the whole system is limited by the constraint. And that's why if you optimize the first step, which is the capture data step, as it seems in the very beginning, you won't have any effect in the rest of the change because the time you saved in the first step will probably be transformed into more waiting time in other parts of the change. But reducing the waiting time of the whole change or the waiting times of each steps for sure will improve the whole process. So you need to identify first the constraints and the bottlenecks of your chain and start optimizing them. And only when you have no waiting time in your process, then you can start optimizing the working times. And how is data ops related to this idea of theory of constraints, lead time, bottlenecks, etc.? Well, since data ops is based on theory of constraints ideas, and one of the core ideas of theory of constraints is optimize the process flow, data ops inherits this idea and tries to apply that to our data projects and products. So, what is DataOps? DataOps, according to Wikipedia, is an automated process-oriented methodology used by analytics and data teams to improve the quality and reduce the cycle time in data analytics. And from this definition, we can extract the core goals of DataOps. These goals are increasing the speed of our process and produce and reduce our errors, which in turn also will increase the delivery speed. That's nothing fancy. That's probably the biggest challenge for any manager in any software and data team. And the values to achieve these goals are these ones. DataOps prefers automatic processing over manual processing because with the former you can achieve faster processing times, and you also will have less waiting times. Also, it prefers repeatable processes over ad hoc processes because you can reduce your code, and without writing new code you can achieve your goals using previously developed code. And also it prefers fast processing over slow processing because slow processes lead more resources usage and more waiting time. Also, it prefers quality and reliable data over data with errors because obviously nobody trusts on data with errors. And DataOps prefers self-service tools over dependencies, and because if you need to make a specific request to get some data, it will increase blockings and waiting times. And after all, DataOps also prefers real collaboration across team members over project coordination because team members need to live in a good ecosystem to be productive. So next, I'm gonna show you some useful practices to introduce in your data projects and teams that will help you to increase speed, collaboration, quality, and all of the previous values. First, you need to productize your processing code. This means that you need always to write generic code that will be used in several projects. Don't write code to be used only once because that code you need to reduce and your code need to be used as much as possible. This is a very basic engineering practice, but you will be surprised that non-engineering profiles fail on this. Also, some tools like Jupyter Notebooks doesn't help too much to achieve this thing. Next, you need to test both your data and your code. Most data projects made are made of steps like this, where one input data set is transformed by a piece of code to an output data set. And you need to make sure that your data is correct, both in the input and the output. And also you need also to make sure that the code that transforms the input into the output, that's what it should do. So testing code is a best practice in any engineering team out there. And if your processing code follows some rules, it shouldn't be too hard to test your code. And at the end of your testing, you will have a binary response if your code does work or it doesn't work. But testing your data is usually trickier because data is not as binary as code. The data rarely is totally right or totally wrong, and it's usually at some point of the middle between the right and the wrong. So test your data. In order to test your data, you usually need some statistics tools to decide if the data is good enough or not. And in the real world, your processing is not just a simple step, but a pipeline of several steps. So you need to test the input code and the output of each step. As we previously said, DataOps is based on theory of constraints ideas, and you'll need to measure your process in order to detect your hidden constraints or bottlenecks. Without that, you won't be sure if there is room of improvement in any part of your chain. And also, as previously said, you need to measure not only one process, but the whole pipeline of processes. Also, in order to increase your collaboration across your team, you need to make your code more reusable, and you need to make your code more accessible. And DataOps encourage you to use version control systems like Git or so. And also, when possible, you also can apply this idea of versioning, but in this case for data. If you are able to version control your data, you will be able to go to any point in the past and recover the state of your data at that point. Also, DataOps encourage us to use containerization, and that way you can make your processing code more portable to any platform and environment. With this, for instance, you will be able to run your production code in your development machine without any fear that the code will run exactly the same in both environments. And also you can include some of your immutable data in your Docker containers, and that way your data will be more accessible to your code. And if you use containers, it would be quite easy to have those containers running in different environments. So you don't want to run your test in your production environment for sure. So what you really need is to have a production, staging, testing, and development environments. And containerization, again, can help you to achieve this. Also, one of the best practices in DevOps and software engineering in general is to make your deployments more frequent and more smaller and more controlled. So if you make one deployment per month, for instance, that probably will include a lot of changes and bug fixes. So it will be quite difficult for you to make sure that nothing is broken. So if you increase the frequency and you run one deployment per week, for instance, probably less changes will be included in that deployment, and you will increase your confidence in that deploy. But if you are able to go even faster and make one or more deployments per day, you will be sure that only one tiny change is deployed each time. And also this way, changes and feature requests and bug fixes get to production faster, because one change or feature doesn't need to wait to the rest of the changes to be deployed and used by the users. And last but not least, you need to democratize your data access, and that allows you to improve your collaboration across your team members. If you are able to create self-service tools, your data consumers will be able to get data when they need, as they need, without waiting for others to shape that requested data. And also, this data will have less errors because there is not manual intervention, and nobody needs to produce that data set for this case. So finally, as you can see here, all of these practices will help you to achieve the goals that any data team really wants, like increasing the speed of your delivery and reducing the errors of your data. And that's pretty much it. So with this talk, we learn how DataOps can help our teams to achieve faster cycle times, less errors, and DataOps is a valuable concept and a good methodology to achieve for our data teams. Thank you very much.
Thanks, Jose. That was a great talk. Definitely a great and interesting concept for businesses. So if anyone has any questions for Jose, you can leave them in the Q&A panel and he can get to them. Does anyone have any questions on that talk?
Are the questions supposed to be in the chat?
They're in the Q&A panel, but I don't think anyone has left any questions just yet. There doesn't seem to be any questions yet. Is there any other part of your talk that you want to expand on or? So Ivan has said, do you recommend any tools?
Well, there are some vendors out there that they say that their platform is DataOps aware or it's the platform for DataOps. I don't think you can say that thing because, you know, DataOps is a methodology, is a culture, as long as DevOps is also the same, a culture. But I would say that any data tool that allows you to go faster, to integrate better with other tools, to collaborate better with your colleagues, and have or use better those values is a valuable tool for DataOps. But I wouldn't say that you need to use this or that tool to follow DataOps principles.
Okay. There's a couple of questions coming in now. If you can see them, Jose, or would you prefer for me to read them out to you?
I can see them.
Okay, no problem. I'll read them out to you. So one Rizla says, I suppose it's a bit of a follow-on from the last one, but any recommendation on, can you recommend any data version control OSS?
I only used one data version control system called DVS, but I don't have experience with others. DVS is more file-centric, so you can version a whole file, and it's more used for machine learning trainings or processes that start with a file. And I don't have any that data version for databases in mind, so I only know about that dvs.io. I think, I don't know.
Cool. Lorenzo says, what kind of small-scale automation practices do you suggest for budding developers?
So automation, can you repeat it?
Yeah, what kind of small-scale automation practices do you suggest for developers?
Automation, yeah. Well, automation is a wide thing, and I think we need to see how DevOps people are doing these things, because automation is the same regardless you are doing software development or data development. And yeah, I would say that I will follow the best practices and principles using in DevOps culture for automation.
Great. Let me see what else we have then. So Manpreet says, what would you recommend are the fail-safe options when automated part of the data ops, as it's not expected that automated part would be 100% accurate?
What do you recommend for what?
What would you recommend are the like basically the plan B if the automation isn't 100% accurate?
The fail-safe option. I don't know. If you mean about writing tests that can break easily, I mentioned in the talk that you should pay attention to testing data with statistics, because when you are testing your data set, you cannot conclude that the whole data set is right or is wrong, because probably some parts are right and some parts are wrong. So I would say that you need to set some kind of thresholds just to figure out if your data set is good enough. It wouldn't be perfect for sure, but if it's good enough for you, that would be enough.
Cool. We probably have time for just one or two more, but Jared said, is there any best practices that should be used for testing data? Are you testing the actual data or just that you expect a certain amount of data? There is also a similar question there on recommendations of data sets for testing.
Yeah, for the tool, we use Grid Expectations, which is a Python framework focused on testing data, which is quite great. And for the other question, best practices, Grid Expectations enforced some best practices. I would say that one is already mentioned about testing against statistics, not hardcore or rigid values. And regarding the testing the whole data set or just a sample, sometimes you cannot test the whole data set because it's too big. So if you can afford that, it would be great if you can test the whole data set against those thresholds. If not, you need to choose or select a sample in your test and use that against your test.
Great, cool. Okay, there is some more questions there, but we probably won't get time to go through them unless, Jose, if you want to take the time to look through them yourself. Otherwise, we can get them followed up after the event. But we're going to move on to our next talk now. And our next speaker is Alfonso de la Garra. He is the CTO of Apputech, and he's going to talk to us today about overcoming price variations in the search of real-time pricing. So obviously, in today's online world, prices change so quickly. So it's important to be able to stay on top of that to manage B2B and B2C strategies. So Alfonso, do you want to say a few words before we start, or should we jump straight in? You're muted, by the way, just in case.
Sorry. Excuse me. Today is a hard day in Peru. Well, we have an Congress strike.
Oh, right.
Yeah. That's amazing. Really, it's terrible. We don't know how it happened. Well, don't worry. I wanna share with you my presentation. I recorded previously. I will start, and after that you can
Yeah,
as you want. Okay.
perfect. Yeah, I'll play it from here, so we have it here. Don't worry. Okay.
Okay.
Good day, my name is Alfonso de la Guarda, and we start with overcoming price variation on the day in search of real-time pricing. Well, day by day, the beginning of the adventure. About 7 years ago, I had twins and I had to deal with products they needed, right? Mainly diapers and formula. Faced with such a variable market but small compared to other economies, my wife Cecilia and I began to identify the products that we needed at the best prices in multiple stores, including, in addition, the trends to their offers, all in order to obtain the highest value for our money. Our dreams, our problems. How do we build something that can help thousands of people identifying the best prices and also monetize at the same time? With my friend and partner Martin, our CEO by the way, we start to work on the problem and the solution, of course. And we can identify some challenge. Shops change their prices daily on demand, even multiple times during the day. They can be lighting offers or not, it does not matter. The price changes. Many businesses are not adequately technified, do not offer an online solution where they share their prices, or simply they know no technology or electronic commerce. The products have different names in each store, and even these are not really what they communicate or advertise. The prices vary by the sales channels, but also by the form or means of payment, and even if there is a benefit or coupon. Finally, we have to deal with image, photos of the products, the specifications, in short, some additional problems. Pristims, a platform for B2C and B2B. There is a whole internal debate about the name, but finally we were left with Pristips. Prix for price in Swedish and tips for advice recommendations. With the supposed problem, we needed to build a solution that could meet all the challenge and not only helps people but also companies. B2B. Obtain prices will not very complicated with the appropriate technology resources such as scrappers, right? But in conjunction with the rest of the problems, the situations become more complex. For B2B, we need to even reach the retailer, particularly in Latin America, there is a tendency to make purchases in market in a small store and not necessarily in supermarkets. So your proposal must include multi-channel resources. We have to deal with it with using visual recognition. From the B2C side, we have to build a solution that allows to search and compare prices, but also alerts and other features to always have the best price to the consumer. With the traffic, we can identify the preference of the consumer, right? Technology and challenge. The architecture of Flixtrix was designed on the knowledge we have in the Peruvian market, but also in the generalities of the Latin American market. Something important, merchants do not like to be compared and less to be scrapped. Many companies spend resources preventing this from happening, although they can only make it more complicated but not impossible. Fun fact, in Peru, until the beginning of 2019, only a large business uses Cloudflare. Today, 90% of the business do it to try to block us. They think that can do it can. Scrapping techniques according to Pristips. We have coined two terms: net fishing, which is our mainly technique. We identify a website, their categorization URLs or hidden APIs, and from that point we extract the data with dedicated bots. The total extraction process depends a lot on the architecture of the web, but this technique allows us to capture thousands of prices in a few minutes. However, due to various factors, network, caches, firewalls, some data is lost along the way, so the efficiency in the scrapping process only covers up to 90% of the web. To increase that efficiency, we execute this process at least 3 times a day. Even we have manager that auto-detect the price change and start to launch a new process to have the 100% of that web. Hook fishing, the typical one-on-one extraction method, where the value and characteristics are obtained from a specific URL. This method is quite efficient but requires a single request per product, which when you scale ends with thousands of additional requests that implicates an effort in their infrastructure. Under the rug, how we deal with B2C and B2B simultaneously. The Pristips architecture has been built from scratch to make it sustainable and scalable. Resources were limited, and we need to fine-tune part of each process in such a way that their consumption is as low as possible. Of course, we use various multiple open source components for each part of our mission, but with the exception of the redundant NAS storage and the container repository, storage only by the way, everything has been installed and implemented by our team. The risky but cost-effective approach has allowed us to have a redundant cluster with more than 1 terabyte of RAM, 320 cores, and more than 20 teraflops of processing per GPUs for less than $2,000 a month. With that installed capacity, we will only take advantage of it in our microservice architecture, mostly developed in Node, Python, Go, and NIM does the job. Workflow. Well, we use and create a custom solution called Scrapit, and it's activated at certain times by default. But this is automatically modified for the process manager that analyzes that products or prices that are missing. The information is extracted, is sent to Kafka cluster, and receives the streaming data. And the process agents starts to many actions. If the product does not exist, it is normalized and categorized using NLP services. The product image is processed and fed in the dataset for machine learning image recognition. It's registered in our Postgres cluster with Temscal, which, by the way, serves up to 5K simultaneous connection. When the product already exists and the price is not registered, is sent to the Redis cluster, which integrates Redis Search as the primary solution for B2C, and that price is updated immediately. A service verified that any customer from us has marked as product as their interest, owned, competition, anyway. And in that case, it's sent to the client's ClickHouse cluster for B2B analysis. It's registered in our Postgres cluster with MScale for persistence and later complex analytics. Finally, a request is sent to the product analysis services where asynchronously they are reclassified, additional information is extracted on the web, opinions, data, reference, articles, or even requests for manual review. Of course, in the whole process, we have many other services running, Airflow, Kong. All the infrastructure allows us to create a solution that not only extracts data, but also processes in the shortest possible time. Scrapix X-Ray. Currently, in Peru, we collect some 2.7 million prices daily, distributed in more than 115 stores nationwide. That does not include the are entered through catalogs or automatic visual recognition for key market or retailers. Features. Scrapix is a solution built from scratch that integrates advanced functionalities such as intuitive rotation and balancing of proxies, including Tor network tunnels, rotation of user agents, WAF anti-blocking algorithms such as offered by Cloudflare, symmetric multiprocessing, low RAM consumption, and also integration with Splash and or Selenium for automated processing. One of the greatest strengths is their ability to scale. A containerized Scrapix service can be deployed quickly if, for example, we can download Linio, which, by the way, is for our team is the best online store in Peru. We extract 400K prices in 6.5 minutes with only 100 concurrent processes, consuming 3 gigabytes of RAM and CPUs at 40% with a server in 8 cores. This is actually varies a lot and it depends on the software that supports the consulted web, as well as the size and availability of their infrastructure. We don't know what simulate an attack or cause drops in the web. It happens a lot in the past. Well, all of this is a continuous work and we are still perfectioning our solution, particularly on the side of auto-detect change in design and data structure. We expect that in early 2021, launch the Scrapix tool like open source as open source solution. Real-time pricing, it is possible? I don't want to make it long. The short answer is no. Nobody can or should. Not Google, not Facebook, nobody, because you will have to put a bot in each site asking each second. That obviously causes problems on that website because they will have to deal with many requests per second. Scrapping has to and can be done, but with moderation and with respect for companies and their staff. Having said all of this, you can achieve an effect similar to real-time if you study online commerce and identify the hours where the price change occurred. Choosing those moments to launch the bots and finally obtain the value that consumers and customers seek so much. We have three important advantages when it comes to serving B2B, and we have not been too able to identify any company with those characteristics in the technological ecosystem. We already have the products and prices that our clients need. They don't need to fill out links or identify business. Obviously, there are factors that the clients can customize, such as identifying internet competition, substitutes. You can basically do analytics from day one. We add a layer of information about consumers and their interaction with products, the interest of certain categories, and even consumer habits. We look for ways to get real-time pricing, but with something else, market behavior. Pre-tips, some through America, then the rest of the world. We are market products and prices in your hand. Thanks, Alfonso La Guarda, at your service.
Apologies, I was on mute there. I was wondering why I was so quiet. That's a great talk. Thanks, Alfonso. So if anyone has any questions on the topic even, or the talk itself, please feel free to leave them in the Q&A panel now, and Alfonso can answer them for you.
Yeah.
Cool, I don't think there's any there yet. No, not yet, anyways. Can you see the panel, Alfonso? Yeah, there's one there from Andrew now. And he's asking, what are the sites that you're monitoring? Can you see it? I'll just read it out for the audience in case they don't all see it. But it's, what are the sites that you're monitoring? Are those predefined by you or by customers, or can customers add their own custom sites to monitor?
Well, we have a higher standard, we identify any web with some traffic and we scrap. Usually, the customer doesn't need to say what URL needs to be scrapped. We just scrap everything in the market. Everything can be data and can be used for any of our customers. That's why until now we don't need to receive requests about any store or any place. That is our difference.
Cool. Okay. Andrew says as well, how did you go about determining an optimal frequency and the power required to do it? We deal in real estate and tracking certain things can change so often.
Yes, in fact, that's the problem. We have a service, a monitor that analyzes the previous data and the times that the stores change their prices. At the beginning, we definitely need to put a bot listing every 30 minutes, right? At the start, just at the start, because some webs can accept so much heavy traffic for that. But we need to understand the behavior of the web and how they change those prices. That's why once we determine the price variation, we can have a window where when start the price change, right? And the power, right now we can, if you refer to speed or resources to scrap anything, we have the infrastructure that I said, I indicate, and we can easily manage 100 or 200 requests per second, because Scrapix and all the infrastructure can do that. Obviously, we are start with a small market. 2.7 million of requests is very low, but we can grow easily. In fact, we want to start right now, very soon, in 2 months, for the rest of South America.
Great. And one says, how do you handle dynamic pricing with all the variables involved?
Okay, how you handle dynamic pricing for all the variables involved? Yes, it's in a problem. Well, that requires a lot of effort. We don't only extract one price, if not all the available price. I don't know very well how to work in Europe, particularly, but in America, you can have the same price with the same product with 3 or 4 prices, and also coupons or credit card benefits and all the things. And that requires not only scrapping, if not a team that we have that studies what are the cooperation process between the banks or the business and the customers. Yes, in fact, that is a constant problem. I need every day to people follow any change in the market for finally got all the price variations.
Great. Okay, and then there's one more question from Andre Urban. He says, it's quite a good one. Do you extract pricing information from advertisements like banners, Google Ads, affiliate marketing campaigns, and so on? And if you do, what are the best practices to get the right date, given that the fact that advertisements are heavily targeted these days and depends on a lot of the user. It depends a lot on the user, what the ads they're seeing.
That's a good question. In this moment, no, but we shortly, yes. That's why we start to download all the images and start the image identification, but also in the TV. Okay. But also we have a problem with the popular markets. There is very common in Latin America, those markets. You can work for people in the mostly with closed spaces. There is no supermarket, and they don't have any technology, and you have to identify the images through that's part of our current work right now. Using lens, special lens, we are trying to identify the image of, for example, potato and the price in the banner for the potato. That is a current work in progress, because it's very important for us also have those prices.
Yeah. Okay, great. Thanks for that. There are some great questions, and it was a really interesting talk. I think that's quite relevant now. So our next speaker is one of my talks I'm looking forward to most today, actually, is Michael McCracken. He's a senior intelligence analyst who's worked for lots of companies throughout his time, including IBM. And he's also worked as a military analyst for the United States Air Force. And today he's going to talk about how intelligence services are using open source data and why data fusion is key to their success. So before I play your talk, Michael, do you want to jump on or say anything, or do you want me to jump straight into your recording?
You can go ahead and jump into it. I do appreciate your guys inviting me. This recording that I created last night kind of illustrates kind of the mindset of an analyst. And when working with various data sets, how you kind of bring that together and fuse it is what's the most important in terms of gaining insight. So I appreciate your thoughtful invite. Looking forward to answering questions as this is kind of played out. So it's kind of two hands at once. Over to you, buddy.
No problem, thank you. So like Michael said, leave your questions in the Q&A panel throughout the talk and we can get to them at the end of it.
Let's go ahead and get started. Hello, everybody, and welcome to the Web Data Extraction Summit 2020. I'm Michael McCracken, your speaker, and today we're going to be taking a look at how intelligence analysts use data models and link analysis to fuse this open source data that we're talking about. Now, oftentimes, the hardest part of being an intelligence analyst is understanding the data. Typically, the data will tell you a lot, oftentimes in terms of not only the data itself, but where it comes from, the source of the data, the reliability of the data, the frequency of the data. But more importantly, though, as you're working with the data, how you shape that data and how you connect it to other data sources is what really drives a lot of insight. And it has historically in the intelligence community for many, many years. Like I mentioned before, I'm Michael McCracken. I'm a senior intelligence analyst, and I spent 5 years in Iraq and Afghanistan on 7 missions, working with various data sources, working with various data sets in terms of overt or covert. But more importantly, though, is a multitude of missions that really gave me a strong sense of how to work with this data, either through tools like link analysis that allow you to understand the relationship of the data. Oftentimes, when you're looking at data, you look at it through the lens of a business intelligence analyst as opposed to an intelligence analyst. The key difference being that the BI or the business intelligence analyst is more driven for insight. I'm trying to create insights for a business in terms of their profitability or their market share, whereas an intelligence analyst is more driven around national security and ensuring that their mission is met. So after our session today, you're going to have a much better idea of data modeling, working with open source data. More importantly, though, what kind of questions are you trying to ask of the data? What do you want to do with it once you model it? And then more importantly, though, what kind of answers you can derive out of that and then take action. At the very end of the day, it all starts with the question. What are you trying to ask? And what are you trying to do with your answer? So before we get too much into it, what I want to do is pause for a minute and take a look at what defines an effective data model. You know you have a good data model if it meets 3 criteria. Number 1, you want it complete. Oftentimes, the data sets that you're working with are relatively inaccurate, they're incomplete, or they're not timely. In order to get a much better idea of what's happening either on the ground of a given area of interest or a given subject, you want to make sure that you're working with as much data as you can. Now, when you're working with open source data as opposed to closed source or covert data, you want to work with the data and you want to bring it all in. So that would include timely data. You want to make sure that you can get it as quickly as you can. You want to make sure that if it's unstructured, that you'll be able to pull out the entity and links and those relationships out of it. You want to make sure that you can translate it so you can understand in your native language what the intent of the message is. And you want to make sure that you understand the reliability of it. Oftentimes, the source of the data will tell you more than the data itself. The second thing you want to take a look at is the stability and the flexibility of the data model. You never know when you're going to get additional data sources. They come in out of nowhere. You may seize a hard drive. You may have another website you're scraping that you're not aware of, or there may be a social profile that is of interest that you want to start collecting on, and you want to make sure that your data model is flexible enough that you can fuse that data into it. The worst thing you can do as an analyst is to have isolated data sets that neither communicate with each other or pivot off each other, either through a time, date, location, or through a specific entity, either a person, place, or an event or a thing. But fundamentally, the most important aspect of a good data model is the communication. You want to make sure that it communicates your findings. Oftentimes, when you derive intelligence, you want to make sure that the assessment that you're making using the data model speaks to the actual event as it actually occurred. Oftentimes, data models are incomplete or they're not flexible. But most importantly, though, you want to make sure they can communicate your insight. Sorry. So when you're looking at multiple layers of data, what does that really mean? What you want to do is you want to have the data model be able to lay on top of other data sources. For instance, here we have multiple data sources from schema 1, 2, 3, and 4. Now, the first one may be OSINT data coming from a news source. The second may be car registration data. The third could be biographical data of key individuals. And the fourth may be historical data, where if it's a historical item of interest, that it gives you a much longer lineage of what events may have occurred before. The idea of an effective data model is that you're using the same data model to fuse all this data together. You want to make certain that as you're bringing additional data sources on, that you can do so in a very effective way. And oftentimes it's how you model the data that tells you in the end if you can bring on additional data sources without having to start over, without having to rebuild your model. It just makes it more effective. So first, let's take a look at the basics. What do we really mean by data modeling? We kind of covered that. We looked at the actual components of what makes an effective data model. Let's take a look and peel it back a little further. Now, historically, a data model is often represented as a property graph. And typically a property graph contains what they typically call as an entity, a link, and a property. Now, when I say an entity, what I'm referring to is like a person, a place, a thing, like a noun, or an abstract thought or idea. As you look at entities, they can be shared between multiple organizations, and this gives you the ability to pivot from one organization that shares the same ideology as another. The link describes the concept of the association between the data. So for instance, if you're looking at multiple organizations and how they're related, either through common lineage, a common location, or a common leadership, you want to make certain that that relationship is really well understood. Now, the link can contain properties, and each one of these properties is more of a descriptor or an adjective. For instance, it could be a shape, color, size. For a relationship between organizations, it could be when the relationship was discovered or when it was promoted or announced. It's how the relationship between the entities is what makes it really critical, because it allows you to tie these different data sources together. So if you're scraping data from a specific news article and you want to come back and scrape additional information from things around the historical aspects of that country, then you want to be able to fuse those together. And you can do that through things like a common location or a common belief. There are a lot of ways that you can associate things together, but make certain, though, that you can defend it. Now, when you're looking at data modeling, oftentimes there's what we call old school and new school. For the old school, it was typically data-driven. Now, what does this mean? Well, years ago, before the internet, before the smartphones, data was often really precious in that you didn't have a lot of it. So oftentimes you would start with this known idea, right? I've got a concept, I'm going to work with it, and I'm going to start to bring this data together to either codify, either confirm or deny my belief. If I believe that a specific political party is more important than the other, then I'm going to bring everything together that's going to support my position. Well, when you're looking at the volume of data and the complexity of the data, it was relatively manageable. However, what happened over time is between the internet in 96 or the smartphone in 07, the volume of data became so complex and so large that entities were no longer specific. They became more abstract. When you're looking at ISIS or or Al-Qaeda, Iraq, or any of those, where the ideology became more important than the key members of the event or the actual organization, it became more important to look at it from an abstraction standpoint to be able to understand the organization. Now, as you start to look at the actual notion of abstraction, you first want to ask yourself, why? Why do we need to abstract when you have news articles or news sources that are referring to the same specific political party or specific individual? It's because when you're looking at over a duration of time, and when you're looking at the number of news sources that increase or the number of data sources that increase, the only way you can effectively fuse them together is to be able to abstract their commonalities between them. As a data variety demand, the data variety demands a new way of thinking. So when you're looking at historically, you'd have a very specific data model, which is basically based around the physical aspects of the relationship between your entities. So what does this mean? Well, if you have a person like Michael, and I work for a company like Acme Heating, then that is at a physical level. However, what you want to do is you want to move to that next phase where you're more of a logical aspect, where you're looking at a male or a person to a company, and then you abstract it further to a conceptual model where the level of abstractions are unlikely to change. And the unlikely to change gives you the ability to fuse this data together. So if I'm pulling data sources from 3 or 4 different countries, or if I'm pulling data sources from multiple languages, the fact that you have things that are unlikely to change allows you to build your understanding of them, because multiple people and multiple authors will take different positions on a given topic. But in order for you to understand them from an analyst standpoint, you want to be able to bring these together. And you can do that by making an abstraction of those individual aspects. And then finally, you want to move to a contextual model. And what this allows you to do is where things are highly unlikely to change unless the scope or the operating environment changes significantly. So for instance, whereas before we had a person works for an organization, now we have an agent, which could either be a person or an organization or many or one of each. But it allows you to understand that organization from a very conceptual level or contextual level and understand how they evolve. So let's take a look then a little further at entity, links, and properties. Now, what drives the data model, right? What is that thing that really pushes it through? What you want to ask yourself is, why do the data models, why do you do, or what do you, when you're looking at data, what makes you think it's an entity, link, or a property? Well, your answer comes down to the questions you're trying to ask of it, the type of analysis, and the volume of data that you're working with. Now, historically, link analysis teaches us that entities, pardon me, are essentially a noun. So you have a person, place, or a thing. Whereas a link is more of an adverb or a relationship between those entities, like a father to a son or a person to a home. And then the properties are then acting as those adjectives that describe that individual person, place, or thing. Now, when you're looking at it through that kind of lens, you want to ask yourself, what makes that individual, that person, that place, or that thing, what makes that unique? because if it's not unique, then how are you going to understand how it differentiates it from all the other persons out there or all the other events out there? What are you using to make it globally unique? So for instance, a person, you would fuse the name, the social security number or the national ID, and the date of birth. This allows you to uniquely describe that specific person. And then you want to ask yourself, how are these things really going to converge? Because if I'm bringing data in from 2 or 3 or 4 different data sources, I want to be able to fuse them together. So if I'm looking at news sources from a given country and I want to be able to understand the historical aspects of that country as well as the nations around it, I need to understand what makes the persons, i.e. the leadership of that country, the places that were historically significant, as well as the things that they're interested in, like a geopolitical interest or an economic interest. I want to understand that, but I want to understand where I want to converge or fuse that data with other data sources that may give me additional insight. The other thing that link analysis historically teaches us is the type of relationships that make them unique. Now, if right here, for instance, we have an associative relationship, like a person is a friend of another person, and then you have with that a transactional relationship, like a phone communicates with another phone. So here we have a person is a friend of another person. They have access to a phone, and then that phone then communicates with another phone. Or if you're looking at the idea of a flow relationship, where a person is cited at an event, and that event then flows to another event, and then to another event, you start to understand the actual conceptual aspect of that person as they move through time and space. So let's take a look at links, events, and flows a little closer. So if you're looking at a relationship link, where here I have Sue and Bob, Sue knows Bob, Bob knows Sue. It's more of an undirected relationship. When you know somebody, it's understood relatively easily that they know you, but it's not certain. And then Bob, that owns a car, is a directed relationship. A car does not own Bob, but Bob owns the car. And then the car, then those individual properties would be, it's a Ford Mustang, it's maybe red, it's maybe the year 2020, but Sue drives the car. So you have Bob that owns the car and then Sue that drives it. So the relationship link not only determines the individual relationship between a person to a person, but also a person to a thing. Where this is important to understand is as you start to bring these data sources together and you're looking at multiple sources over time, that relationship between individual entities will change. So you want to make sure that as you're understanding that relationship and you're bringing those data sources together, that you can further understand that over time. When you're looking at a transactional link, where you have a communication device communicates with another device, oftentimes that will be through a temporal aspect. So you have a phone call that occurs at a specific date, specific time, a specific duration, as well as a specific type. Is it a voice? Is it a data call? Is it a text? How are those two communicating? And if so, what other communications are occurring? So if you look at smartphones today, which are essentially a walking computer, you can actually communicate from one phone to another. You can actually transact funds from one account to another that was initiated from one device to another. There is an unlimited way that you can analyze the data itself and continue to start blending this data together, again, to get that rich insight to answer those questions that you're trying to answer. When you're looking at an event, so you can have here where Sue and Bob know each other and they participated in an event of marriage, where the marriage was on the 14th of February 2015. It was at a location of 2343 Main Street, USA, where Bob and Sue are now participating in that event. Those are a directed relationship. And then the event can then host other people, like who actually photographed at the event, who witnessed the event, who was unable to attend the event, or where did the event occur. So there's a multitude of ways of working with the data from an event standpoint that allows you to take that unstructured data, those things that you're scraping from the web, and start to stitch them together to enhance your overall analysis. In addition, if you're looking at a directed link, the direction shows ownership of a link of an entity or a relationship. For instance, Bob is the father of Steve, and Bob is the owner of a Ford Mustang. The Ford Mustang cannot own Bob. So you want to make sure that the direction of the relationship is equally important, because it dictates not only ownership, but it could also dictate influence. So if one event influences another, you want to make certain that you've abstracted that aspect out of the event itself, and then you can start to bring in multiple data sets together and then fuse that level of understanding. As you look at flow, the idea behind flow again is that we're taking a look at Bob and then we're looking at multiple events that he was cited at. So he was cited at 1200 Broadway, at 2343 Main Street, again at 1343 Main Street, and finally at 1934 Main Street throughout the month of February. And as he moved from one event to another, we can superimpose that onto a map and start to get a geospatial aspect of the actual events. Again, when you're looking at things from an abstraction standpoint, you can fuse far more data sources together, and you can take advantage of a lot of the scraped website data that you can actually enjoy. One thing that you need to consider is, as you start to look at these various data sources and you want to understand them, you want to start to understand the concept of an identifier. An identifier is no more than a unique way to describe or globally describe a specific event, times, or a specific event, or a person, place, or a thing. For instance, if you're looking at a VIN number and you want to ask yourself, what if we don't have a specific vehicle in mind, yet we know that they share a VIN number? So if you're looking at, show me all the vehicles that are registered in the state of Ohio over the course of the last 3 months, but I want to understand which vehicles are using the same VIN number, then I can start to understand that if I extract that VIN number as a unique identifier, which is basically removing the meaning of the data itself, but understand that the relationship between the VIN number and the vehicle is what's most important. So you can then start to pull that out. Here we have a vehicle with a specific VIN number, and we have multiple vehicles identifying that specific VIN number, which may be indicative of fraud. You can do the same thing with the date of birth. For instance, what if you have an identifier and you want to ask the database, who within my database has the same date of birth without knowing a specific date of birth in mind? What this allows you to do is extract out that date of birth and then start to associate it with multiple people. Then we can start to understand not only who shares the date of birth, but we have no idea what the date of birth is. So historically in analysis, it would be called an unknown of an unknown. I don't know who has the same date of birth. I don't know who they are or what the date of birth is. I just know that multiple people share the same date of birth. And this is one way of using link analysis with web scrape data. When you combine them, you abstract it up one level, pardon me, then you can get a much better idea of the analysis that it affords you. So what if you don't have a specific network identity in mind? You know, they share the same email. So oftentimes you'll see this in identity fraud, where you have multiple accounts that were set up by the same email account. And the same email account could be treated as a network identity. It allows you to identify that email address as that network identity, and then you can start to pull that out of your various data sources. You can also find hidden connections using this sort of approach, where if you don't have an idea of an email or or anything else like an IP address, then what you can do is start to create these multiple identifiers without any indication of what it actually is. It's the fact that these various entities share that same common aspect together is what's most important, not the aspect itself. So for instance, here we have network identity A, B, and C. They all share the same identifier, but I don't know what the identifier is. It could be a date of birth, it could be an email address or an IP address. It doesn't matter. The fact that they share something in common is what matters. So as we start to take a look at this sort of idea, you can actually layer onto the physical world and then layer underneath that a communication layer. So for instance, at the physical level, you have a person that is linked to another person through a common location where they both work at, and then they own a vehicle, or they have a national ID, or they work for an organization. but under the covers, they communicate because they have different network identities. And these network identities then communicate with each other through other means. It could be email, could be Facebook chats, it could be a number of ways. But what you're able to do is to pull those two worlds together. So this allows you to fuse those data sources together using a creative way through link analysis that allows you to start to understand the relationship between the data as opposed to the data itself. And then finally, we're going to take a look at analyst-driven. We took a look at data-driven. Let's move our focus over to analyst-driven insights. And we're going to start with this with a target list. Now, a target list is no more than a list of interest that I want to start to identify those items that I've abstracted out of those multiple sources, and I'm starting to understand them from a contextual standpoint, and I want to know what they share in common with others. So for instance, here I have person X and person Y. They both are listed in a target list A, but also person Y and Z are listed in target list B. What this allows you to do is to keep the association of these lists as separate subsets of data that you can then analyze over time. This gives you a much better insight as you can watch organizations evolve and then where membership may move from one target list to another. So let's jump into some examples. The one that we're going to take a look at today is around social media. Now, social media, right? We all have either Facebook or Twitter or whatever social media profiles or what other social media websites you want to partake in, and you have social profiles that communicate with one social profile to another. When you start to peel it back and you start to understand these social profiles and you start to break the data down, then you get a much better idea of how they're related to each other. So for instance, if you're looking at the messages that are sent from one social profile to another, it tells you a lot. So for instance, here we have a message that was sent by social profile A, but if social profile A never receives messages, all they do is send it, that gives you a much better idea of what they're doing in that network. It could be broadcasting, they could be recruiting others, it could be just on a specific role within that organization where they're just disseminating information. Whereas here you have profile B that they may be just receiving information and they may be using this social profile on this social platform as a communication way, but not necessarily interactive. It's not bidirectional, it's just single directional. Now, as we start to take a look at other aspects of the social media profile, you have an IP address. Now, the IP address could be where the account was created. It could be where the account actually posted information from, or it could be where the account was actually using derogatory information and they actually were canceled. So the IP addresses will give you much better insight in terms of not only the underlying relationship between these social profiles, but also more importantly, though, what are the things that are in common? So if you come across any IoT data, or you come across other social platforms where those IP addresses are equally seen, it gives you a much better idea in terms of what's going on between the relationships of the data itself below the covers. Now, also you can take a look at the screen name. So social profiles will have unique screen names. Sometimes they're just happenstance that one shares the same profile screen name as another. Others, it's more indicative of a naming convention of that organization. There's a lot to be said for that screen name in terms of what kind of insight it can provide you. And then from here, you can also take a look at the email address. Again, anything that's going to give you greater insight on the relationship between one social profile to another. And then from here, you can also take a look at the user device. Is it an Apple? Is it an iPhone? Or is it an Android? Or is it a laptop? How are they communicating with and what kind of device is it? And have you seen this device before? And then finally, what you want to do is you want to take a look at the location. Now, the location could be one location in terms of the latitude, longitude of where the IP is actually logged in, or it could be the location of a photograph that was taken by that social profile, or it could be the location that's promoted in terms of a potential meetup. So there's a number of ways that you can actually shape the location data and you can extract it out of the social profile. Again, you're wanting to take those multiple data sets that you're scraping from all these locations and you want to abstract those single things out of it and then fuse it together. That's the key. So let's take a look at multi-purpose design as our final stage for today's talk. So for here, we have multiple data sets together, and we're going to use the same common model. So here we have airlines, flights, and passengers, where the flight tail is a key focus. And then you have airports that are traveled from and to, and then the flight manifest that contains passengers. As we turn our focus to vehicle movements and checkpoints, where you have a vehicle checkpoint, and then you have a manifest and multiple passengers, either through a driver or a passenger, we want to use that same data model. And then you want to take a look at package acceptance and delivery for like a post office, where you have a pickup and a drop-off point. Again, the package delivery gives you much better insight. And then from here, you can also take a look at vessel and cargo shipments, where again, you have that same vessel, you have that pickup port and that drop-off port, but the cargo details may give you critical insight in terms of as cargo moves from one ship to another, and you're looking at this web scrape data that gives you a much better insight of what's going on. And then now you can abstract all that, where you have a vehicle and you actually abstract it to a site, from one site to another. And the payload itself is, again, either being that manifest data or that cargo data or that package data. And you're seeing it through an abstraction level that allows you to fuse it all together. If you have any questions, we look forward to answering them. And again, thank you for joining us.
Thanks, Michael. That was definitely a very insightful talk. There's a lot to take in there, and definitely ways of looking at data that I probably would never have even thought of. So if anybody has any questions for Michael's talk, you can leave them in the Q&A panel. I see you've kind of answered some already in the chat. So I'm assuming most people probably have had a chance to look at that. But yeah, definitely a lot to take in there. Great talk, really interesting. So thanks for that, Michael. But if anyone has any other additional comments or questions, please feel free to leave them now. Someone was asking, will the recordings be available after? Yes, we'll have the recordings out probably within a day after the event. Yeah, there's a lot of talks. I know that are going on track 1 and track 2, and they're all kind of a lot of technical talks too. So some of the talks will definitely be helped by looking at them again. But now is your chance to actually talk to the speaker themselves, which you won't be able to do in recording, obviously. But yeah, I'll give everyone just 2 minutes after that just to get a glass of water, a cup of coffee or something before we jump into our next talk. There was a lot there. But thanks, Michael. I don't think there's any additional questions, which is great. You might get some in the next day or two. Oh, there is one actually, if you're still here. I'm not sure if Michael is still there. Oh, yes. Keeping up with the amount of data from an infrastructure point of view must be really hard. How do you cut through the noise in the data? Oh, maybe he's gone. Okay. We can get set up for our next talk.
No, sorry about that. So,
no
one thing I want to answer to that, if I may, is if you qualify the data on the front end through sampling, that gives you a much better idea of making sure that as you're looking at these data sources, you want to triage them as fast as possible. So if a data source has something of interest or there's connections in your data, then obviously you want to prioritize that. But you want to be extremely agile in how you analyze the data as quickly as you can. That way your analysts are focused on the most critical data and not being distracted by the noise. Great session, everybody. Thank you, Colin.
Thanks. No problem. Thank you. Okay, so let me have a look here. I don't think there's anything else. There is one from Clement there. Could you provide some resources for further details, maybe examples of implementation of such models? I think Michael is actually gone now, but we can definitely get your question answered. We can send it to him and hopefully he'll be able to answer it for you. Okay, so that was a great talk, lots to it. The next talk we have is also another talk. I'm really looking forward to it. It's something that's definitely an interesting topic. It's the trials and tribulations of crawling the dark web. So it's definitely something you don't hear about every day. And who's presenting this? It's Dr. Gareth Olsen and David Andres. So Dr. Olsen is a leading expert in dark webs with a 15-year track record in cutting-edge research in darknet, cryptography, and distributed systems. And he's worked with governments and law enforcement agencies to develop technical capabilities. And he's joined by his colleague, David Andres, who is a lead developer for the data engineering team at Searchlight Security. So guys, do you guys want to say a few words before we jump into your talk, or are you happy to jump straight in?
Yeah, I'm happy for us to
No problem. So yeah, we'll jump straight into the talk then. And again, if anyone has any questions, put them in the Q&A panel, and Gareth and David can look at them throughout the talk or answer them at the end.
Hi there, and thanks for coming to our talk, Trials and Tribulations of Crawling the Dark Web. My name is Gareth Olsen, and I'm going to be giving this talk to you with one of my colleagues, David Andreas. We work for a company which provides darknet intelligence, so we have a software platform called Cerberus, which allows the likes of law enforcement, governments, investigative agencies, and private entities to investigate criminal activity or other types of activity that take place on the dark web, track actors, record pieces of evidence, and so on and so forth. So it's important that we're able to build effective crawling mechanisms to collect as much data as possible and gain insight into those activities. My background is that I spent more than 15 years in academia doing research into things like distributed systems, cryptocurrencies, darknets, and so on. Over the last sort of decade or so, I've published some of the most influential papers on dark webs, particularly trying to understand some of the activity which takes place and some of the vulnerabilities in those networks. And my colleague David is the lead developer on the data engineering team, building crawlers and data insight gathering tools. Our company is Searchlight Security. That's our website there, and if you're interested in a brochure or some more information about us, then you can visit us at the website there at the bottom. So I guess the first question is, what is a darknet? There are lots of technologies which might comfortably be considered dark nets. The main tool is called Tor. There are others like I2P, ZeroNet, sometimes even cryptocurrencies come under the concept of a darknet. A darknet typically is a place where people can interact with internet-based services, typically websites, but it's difficult to track their activity, to sniff their traffic, to understand who's doing what and who's communicating with whom. That's essentially the objective normally of a darknet. Now the main one is Tor. And the way Tor achieves this is by having a set of relays which you'll pass your traffic through as you're browsing the net. So let's say you go to the New York Times, for example, your web browser will connect to the Tor network, bounce through several relays, and then come out to the New York Times' website. The New York Times' website will simply see the address of the last relay which your traffic came out of, so it won't know who you are, and your ISP will only see you communicating with the Tor network in an encrypted tunnel, so it won't actually be able to see what you're doing and which website you're going to. So Tor essentially provides two things, anonymity and privacy, albeit not at the same time. They don't know who you are, but they know what you're doing, they know which web pages you're going to. And then from your ISP's perspective, they don't know where you're going, so they don't know what you're doing, but they do know who you are. So it's about the inability to connect those two things together, identity with what it is someone is doing. Now that's the Tor feature which allows you to browse the open web, so if you go to New York Times or the BBC and so on. Tor also has another feature which is, I guess, called the dark web. Tor calls them onion services or hidden services, and these are in essence dark web servers where the server doesn't know who the user is, and the user doesn't know who the server is. So if you wanted to host a website anonymously, Tor provides you the ability to do that. And unfortunately, this has led to the growth of darknet markets, which are selling drugs and criminal products and that sort of stuff. principally because they can host these services with almost complete impunity because no one knows where these servers are. Now, Tor has users all over the world. The users are broken into two components, really. There's so-called ordinary users, and then users which are using an evasion technique, which is kind of designed to hide the fact that they're even using Tor so that they can't be blocked or stopped from being used. Ordinary users, the vast majority are in Western countries, the European Union, the United States, and so on and so forth. When you look at users which are using evasion techniques, you start to see them in slightly more repressive regimes, places like Iran and Russia and so on, who are, certainly in the cases of like China and Iran, actively trying to block people using Tor. Because if they can connect to the Tor network, that essentially bypasses any in-country restrictions those users have. So it might be if you're in China, for example, you're not able to visit YouTube or certain websites which expose stuff which the Chinese government don't wish you to know. Now, some users get past that by using VPNs, but VPNs are very easy to block, whereas Tor provides these evasion techniques which makes it difficult to detect what someone is doing. Now, if you look on the Tor Project's website, they say the tool is used by whistleblowers, journalists, bloggers, essentially for a plethora of good reasons. The reality is that if you look at the scientific literature, the overwhelming consensus is that Tor is predominantly used for malicious activity, but principally drugs, child exploitation, the sales of weapons, and other criminal products. Probably the most famous examples are the so-called Silk Road, which was set up in around about 2011, 2012. This is the first darknet marketplace, which proved the concept of having an anonymous server hosting an eBay-style site that's selling weapons and drugs and so on and so forth, and taking payment in a way which makes it difficult for law enforcement to track. So in the case of Silk Road, they took payments in Bitcoins, and you would just access the Silk Road website by using the Tor software, and then it would give you a Bitcoin address, and you'd pay the money through that way. One of my studies in the last 5 or 6 years showed that actually, when you look at the darknet, the vast majority of users are visiting child abuse websites, and these really are unfortunately the most horrific stars of websites. They're relatively small in number when looked at the sort of total pool of websites are available, but there's certainly the bulk of users are going to those sites, and also the drug marketplaces. And also, if you ever watched Edward Snowden giving interviews, you'll see he has a Tor sticker on the back. He allegedly used, or at least claims that he used Tor to communicate with Glenn Greenwald, the journalist which exposed, or rather published, all his leaked documents from governments, from the American government. Now, if you ever want to use Tor or to go on the darknet, probably the easiest way is to download the Tor browser from the Tor Project's website, and you install the Tor browser, and you get essentially a Firefox instance, which doesn't look a great deal different from Firefox, with the exception of some plugins. And you can just start browsing the web normally, and it will route your traffic through those multiple relays so no one knows who you are. And you'll also be able to visit a special class of sites which end in .onion, and these are the so-called dark net websites. So they are anonymous servers where it's difficult to find out where they're located. So both you and them will be anonymous to each other, but you'll be able to browse their website, they won't know who you are, and you, at least in theory, don't know who they are. Now, the onion addresses often have a sequence of random looking characters before the .onion. That's because it's essentially a hash of a public key which is used to encrypt the traffic to that site. So it gives you the ability to verify the site is who they claim to be, kind of like in a similar way to the SSL and TLS certificates do. Now, the choice of Firefox here is interesting. Firefox has an extraordinarily bad security record. And we have seen law enforcement agencies around the world using vulnerabilities in Firefox to de-anonymize users and identify who they are, and I think at least 10 or 11 cases now. In terms of size, if you look on the Tor Project's website, they currently give an estimate of there being around 150,000 users, 150,000 darknet websites. The reality is that the bulk of those websites disappear within about 24 hours of being published, and that's maybe because people are trying the system out and they decide to run it for 24 hours or a few hours and then shut the website down, or that it's bots that are setting up temporary sites that only last for a certain period of time. So although it looks like there's a large number of websites, the reality is if you were to point a crawler at the dark web, that you only find about 15 to 20,000 websites which you could access at any particular point in time. Now, most darknet companies that you'll see just point a crawl at the dark web, and that's what they do. They collect those 20,000 websites or so. We have some advanced techniques which allow us to find darknet sites which are not connected to anything. So there will be no sites that you would crawl that would link to these websites. So they're kind of like closed communities where no one else knows about them. And we found some really interesting things just by being able to locate these sort of island sites. We've found botnet command and control servers. We found like carding bots, which are basically stealing money off people's credit cards. We found back-end infrastructure for big like criminal activity taking place on the dark web, and so on and so forth. So these sort of unconnected sites actually provide a pretty good wealth of criminal activity when you start looking at those. And most crawlers, in fact all crawlers, won't pick those up. I'm going to hand over to my colleague now, David, who's going to talk you through some of the specifics in crawling some of the darknet marketplaces.
Problems with crawling the dark web. There's quite a few problems that we come across when crawling the dark web, quite a few barriers which create a few issues. Network stability is a big issue. Sometimes Tor just treats sites as down even though they're up, just because they've been cached as down, which can lead to some annoying uptime inconsistencies. The network can also be quite slow. There's a lot of users, and the way that the Tor's created means that typically the traffic's quite slow. Sometimes it makes it quite hard to write crawlers as well, because you have to wait sometimes even a few minutes just to connect to a website. The captures are also a bit of an issue. They're not always text-based. They used to be mainly text-based, but now there's a bit more innovation behind them. They can't use services like reCAPTCHA because they're on the Tor network, and they can't use JavaScript, which we'll get onto later. Some have tried to use reCAPTCHA and failed, but because it led to some interesting results, because the reCAPTCHA traffic is coming from Tor, which means Google blocks it, and the users on the site couldn't actually log in, which was a bit of an issue for them, I think. But yeah, just because of the way that the Tor's structured and some of the technologies can't be used means that they have to innovate with their captures. Anti-crawl mechanisms, they're not typically too advanced. They usually rely on like a few tricks. They're typically pretty easy to bypass once you know what they're doing. Site turnover and rotation is also a bit of an issue, because most Tor sites come up and then disappear pretty quickly, and big sites, especially the markets, tend to rotate mirrors quite a lot, which means you have to keep track of up mirrors, down mirrors, valid sites, phishing sites. There's a whole load of things to keep track of, which makes it a bit tricky sometimes. And some sites are just terribly made, which is quite possibly the best anti-crawl method that they've accidentally employed. There was a site which was pretty much styled with just p tags and tables, which was a bit annoying to crawl. I mean, it's doable, but it was just a bit annoying. I don't think these guys are typically very good web devs. Onto dark web captures. Used to mostly be text-based, but they've kind of moved away from that now. That's probably due to the recent usage of capture farms and machine learning. So text-based ones aren't typically too useful nowadays, because you can just pay some money and get 1,000 of them done for $1, or just employ a machine learning algorithm. Used to be fairly innovative. Or has to be fairly innovative. No JavaScript can be used, of course. This is because most browser exploits use JavaScript. There have been a lot of attacks in the past using JavaScript to de-anonymize Tor users. So within the community, there's a large distrust in JavaScript. So people tend to not use it. And if a site does want to use JavaScript, they're usually labeled as a law enforcement site. They're usually image-based captures rather than text-based, so selecting different images of a certain category and stuff like that. So kind of mirroring stuff you see on the clear web, but there's a few other issues they can't use, because they can't use JavaScript, so it's mainly done using like forms and stuff. Due to the large number of sites there's a huge number of unique captures. So unlike reCAPTCHA, a lot of sites in the clear web use reCAPTCHA. But these sites typically roll out their own ones, so it means that there's a large number of captures which you have to be able to solve. There are some generic ones, however. Some of them are sold, some of them are given away. A lot of sites share. There have been some interesting alliances between sites, which has been quite cool to see. But but we'll get on to that in a minute. And it's generally a cat and mouse game. So if they create a new captcha, it's usually only a matter of time before we're able to solve it. So here's a case study for a drug forum that we crawl. I'm not going to mention the name of it, but it's a very, very, very popular site. It's got a very large amount of users. Probably one of the biggest drug forums out there. The staff are absolutely crazy, always boasting and always going. The things that they post are just insane sometimes. And due to the large user base and importance of the site, there's the largest amount of spam and DDoS attacks, mainly from markets or disgruntled users trying to influence other markets and stuff like that. So it's in their best interest to try and make a foolproof captcha which is pretty unbroken. So the first captcha they used, they originally had a text-based one, but they moved on from that because it was getting broken so easily. And as you can see on the right, there's an example of it. So there's 3 rows of 3 shapes, and the shapes are either colored or not colored, and you get given a 3x3 grid, and you have to press on the grid which ones are filled in. So you pick the top right one, the 3 ones in the middle, and the one in the bottom. And there was a new format of captcha which we've never seen before. It's quite innovative, I thought. And the admin could not stop boasting about how new it is and how exciting it is. He said there was going to be the captcha to end all captchas. It was shared between multiple sites. Some markets helped collaborate on the captcha which they used. And the whole point of the captcha was it's supposed to offer like modularity and customization. You're supposed to be able to like customize the icons and backgrounds used to try and minimize the amount of solvers that can be used on your site. And it was, as I said, it was supposed to be the captcha to end all captchas, but it was broken in 6 days of release. Many big forums and markets rolled out on their platforms as well, and it was an absolute disaster because now instead of having to solve all the captchas on all the sites, I've now just solved one captcha on many sites. It was inevitable considering they released the source code of the captcha generation. I mean, what did they expect was going to happen? So they released the whole backend, how to generate images, how to do all of this. It was all published, all open source, and the admin was very sad. He said, "So our captcha got broken, guys. If you didn't notice, LOL." So I guess that motivated them to make captcha number 2. Fast forward 2 months, there's a new one. As you can see on the right, there's a list of categories, and they take a random image from the category and then turn it into like a star constellation kind of thing. And once again, the admin was very excited. He was posting some boastful stuff. He said the captcha woke him up, dripping with adrenaline running through his veins. He said a machine learning model would be completely useless, and he said to say this is genius implementation is me being humble. So this guy was very, very confident that this captcha would work. And this captcha was surely going to be better, right? No, I broke it before lunch the next day. It was quite a nice win. It was trivial to solve. There was no machine learning. Their mistake was only having 25 categories. So 1 in 25 guesses is going to be right, and that's all you really need. To mount a spam attack, you probably need something higher than that. But it's to crawl the site. I mean, it is pretty trivial. And the captcha backend was not published for other sites to use this time, so they learned their lesson. However, they have used the same anti-crawl methods from the last one, so it shows that they probably copy and pasted some of their back-end infrastructure and just kind of changed the front end on it. So this motivated them again to make captcha number 3 months later. The admin had actually learned their lessons. They weren't boasting in the comments. They would just say, "Oh, we're rolling out a new captcha." The idea of it was supposed to be kind of similar to Google's reCAPTCHA, but it was done in PHP, of course, because there's no JavaScript. I think they actually harvested their images from Google reCAPTCHA as well, if I'm remembering correctly from one of their posts. And the idea was kind of taken from one of the other sites which is doing a similar thing already. I think they helped, it was the same site that helped last time. They helped again with the captcha, I think. And broken in 2 days. Once again, it was quite trivial to break once we come up with a tactic for it, and yeah, so I think that's the one they're currently on now. So the conclusion for the case study: don't publish the generator code for your captchas. That's only going to lead to some mistakes. People just quickly creating thousands of test images, it will be pretty easy to make something to break that. Don't make arrogant posts about how good your capture is so quickly and then have it broken so fast afterwards. And yeah, usually captures are breakable in like a relatively small time window once you've come up with a method of doing it. So yeah, now we're going on to anti-crawl methods. There's not too many anti-crawl methods that are utilized in the dark web that just because of how it's made. Really, they're quite limited because mainly they can't use JavaScript. So it means that they can't employ any kind of like proof of work or any like machine learning stuff or anything like that, just because they can't embed any JavaScript on the page, which makes it a bit of an issue. Also, they have some annoying tricks, but they're usually pretty simple to get past. There's nothing too advanced. They're usually more inconvenient than anything else. And also, due to how Tor works, you can't really IP ban someone. It's just kind of, it's just, they can't really get past the people just creating new accounts and stuff, really. And so this brings us into the next slide, which is another kind of cool trick which was used, but I'm not really sure if it was a trick or not, but sites don't necessarily return the correct status code. There was one site that we were crawling which returned 200s on pages which shouldn't be returning 200s. Every single page was returning a 200, which kind of threw us off a bit. And there was one site where it was returning 500s, but completely valid content in the HTML body, which also threw me off a bit. But so yeah, sites don't necessarily return the correct status code. They sometimes attach content to it. Don't rely on the site devs actually being good developers. I'm pretty sure these guys aren't typically fully trained web devs. I think sometimes they just buy a lot of code and then just pay a freelance person to stick some stuff on top. But I'm not really sure how that works. But yeah, they're not typically very good. But you should pay attention to the content of the response, not just the status. That can be quite misleading. So make sure you look out for that. And as it says in Hanlon's razor, never attribute to malice that can be adequately explained by stupidity. I'm pretty sure the 200 return on every page is probably just like sloppy web development rather than anything else. But I'm sure sometimes it's deliberate, but it's always worth looking out for as an anti-crawl method. Some anti-crawl anecdotes and methods. So one site we were crawling, I found an accidental bypass through the capture because I typed an exclamation mark at the beginning of the capture string which I was inputting, and that miraculously let me through even though I got the capture wrong. So I went back and tried it again, and it turned out that the admins had actually implemented a nice capture bypass. They don't have to type in the capture, which I thought was quite funny. There's also slight instability. One site we were crawling on the anti-DDoS page. If you got the capture wrong, the site actually crashed, like the entire site, not just the anti-DDoS page, which made it an absolute pain to crawl. Like it was ridiculous. And a lot of sites like rotate their mirrors and go up and down, and sometimes you have to keep track of what mirrors are up and down, like I said earlier, and it makes it a bit of a pain to crawl sometimes. And there's a lot of time-based anti-crawl mainly. That's kind of the main one we see. So mid-crawl they'll log you out of your account or serve you up a capture or something like that. But honestly, the anti-crawl methods aren't too advanced.
So thanks, David. That neatly brings us to the end. I guess the main takeaways are that lots of darknet websites are made pretty poorly, and that can produce interesting challenges in trying to crawl them. Compared with open websites, clear web websites, which are normally written much better. Most of the captures which we've come across, whilst initially appearing to be very difficult to break, we've normally cracked within 24 hours, and we've now got a pretty good team that's can crack these fairly quickly. The anti-crawl tricks often defeat beginners at crawling the dark web, but once you learn the tool set which is available for doing anti-crawl on darknet sites, then it becomes much easier to get around these things. And we've started building middlewares which automatically now detect these anti-crawl mechanisms and bypass them automatically, so we don't have to worry about them when we're trying to crawl them now. The problem's just solved automatically. So just one final point to say that we are currently recruiting for software developers and crawler engineers, so if crawling the dark web and tackling some of these challenges sounds interesting, then please send us your CV to inquiries@slcyber.io. We are looking for people that would preferably be willing to work on site, but we will entertain remote roles if that's a barrier to you. So thanks very much, and we'll be in the Q&A very shortly to answer questions.
Thanks, guys. That was a really interesting talk, especially related to the captchas. It seems like you take good pride in defeating captchas as quick as possible. So we have a couple of questions. One is in the Q&A and the other is in the chat. I can read them out for you. So Jan has said, sorry, let me check it. Does it make our life easy using combination of Linux, Kali plus Tor to surf the dark web? How safe to visit Silk Road using Tor?
The easiest way to get on Tor is just to download the Tor browser, which is that little screenshot I showed you of the Firefox looking window, and that will get you onto most of the darknet sites. It's relatively safe to go to some of the big marketplaces and have a browse around. You want to avoid sort of clicking around off that sort of, I guess, that section of sites, because you very quickly lead yourself to some quite unsavory content if you're not careful.
Cool.
I'd also like to add that I don't think the Linux distro like Kali doesn't really affect the security of it. I mean, there are Linux distros specifically built for that kind of thing, but Kali versus Ubuntu versus Debian doesn't really make much of a difference.
Cool. And then there is a couple of questions in the comment section as well. Rob says, Tor was created with government funding, I understand. How does this square with the often less than legal use cases?
Yeah, so I guess for those who are not familiar with the background of Tor, Tor was originally a US government research project to allow spies who are in foreign countries to essentially communicate back to the US without their host country being able to monitor their activities, or even ideally know that they were communicating back to their host country. So that was initially a research project. It turned into an open source project to develop the so-called Tor, which is now run by the sort of I guess they're not a charity but a foundation called the Tor project. And so the idea is that as lots of people use it, the spies can then hide in the noise of regular users which are using the tool. I mean, the reality is, like just about anywhere where you put any anonymity, you very often very quickly get, malicious actors engaging in that environment. And when you take the anonymity away, often that activity stops. And we see that again and again in a wide range of different places. As to whether the US government should continue funding it, I understand the funding has dropped quite considerably. There is a bit of a push, I think, to try and persuade the US government to stop funding it. But just remember, it's not something that comes from the top of government. The US government's absolutely huge. So, many, many departments in the US government. And I think it's currently the State Department which have lended most of their funding to it.
Cool. And the second one then is, why is there only one Tor, unlike cryptocurrencies?
This is an easy one. The answer is that there isn't only one Tor. There are several darknets. Tor is by far the most popular one because it's probably the easiest to use, and that drives its popularity. It's probably the most well developed and had the most scrutiny. But if you look at the academic literature in terms of state of the art, Tor is not state of the art in terms of a darknet and providing protection to users. The other types of darkness, if you want to look at them, I2P, extraordinarily slow, not a lot of content on it anymore. There was Freenet back in the days where you could upload files anonymously and other people could download them. There's now ZeroNet. There's a couple of messaging platforms which are kind of like darknets as well. I think there's a question for David then next.
Yeah, there's a question in for David. Are there any patterns that you have observed in which sites are especially badly developed, or which are actually more robust?
Yeah, well, as far as badly developed, I mean, a lot of these sites, I think the people that develop them don't tend to look like web developers, from what I can tell. They seem to, a lot of the sites seem to borrow kind of tactics and techniques from each other to try and make each other more robust. And I guess that kind of it can stop beginners from crawling, but as soon as you've kind of got to know the techniques, and it's not really that robust. But as far as badly developed, I mean, I'd go as far to say like most of the sites on Tor are pretty badly developed.
Is that just because they're not going to last very long? They just don't put in the effort?
I think it's kind of a mixture of things. I think sometimes it's just like a lot of people want to start up a market just to make a quick buck and then leave. So they won't bother to sink any money into it. Sometimes it's just because people want to develop it themselves because they don't trust any kind of on-the-shelf software. So they'll try and make their own kind of versions, and it'll end up kind of not as well as a professional bit of software. But yeah, I think it's mainly just people. I think the bigger sites usually have a higher quality in development, but yeah, as you're right, the small sites kind of come up and down, and their quality is pretty bad.
Cool. And then one last question from Clement BM. Actually, everyone's come through as well. But Clement says, do you use machine learning techniques to break CAPTCHA? And if yes, which ones?
I mean, I can take this. We use a variety of techniques from image recognition through to machine learning. It very much depends on the particular capture as to which approach is best. Some are solved via technical means. Some are solved through a combination of image recognition and machine learning. But as I say, it very much depends on the particular capture.
Cool. Yeah, some of them really don't need it, but some of them, yeah.
Then Sajan says, in terms of bad website development, is it something that they're just created for a short span of life, 1 or 2 days, or maybe hours, or for selling stuff illegal? I think that's kind of covered already, but if you want to elaborate on it, go ahead.
Yeah, so I mean, the bad website, it's some sites, some of the badly made sites stay up for quite a while. So it's not, there's not really much of a correlation between the quality of the site and how long it stays up for. However, it's probably safe to say that the ones that do go up and down pretty quickly are probably pretty poorly made. But usually when people make like one of these sites that goes up and down quite quickly, it usually stays up for longer than 1 or 2 days if they're trying to scam and stuff.
Cool. Yep, one more question then. Pierre says, do you have a visual cartography of hidden services? As a white hat hacker, can we have a look at your platform?
Yeah, send us an email at inquiries@slcyber.io. There'll be some vetting, obviously, but yeah, potentially.
Cool. So I think that's all the questions. So like Gareth said there at the end, they're also recruiting software developers and crawl engineers. And you can email inquiries at slcyber.io, which is in the chat there. Yeah, thanks a million, guys. That was really interesting.
Thank you very much.
Okay, so at this stage, we're actually going to take a break. Sorry, just one moment here. That was the last talk. We need to go to that. Sorry, now just bear with me for one moment. Okay, yeah, so we're going to be taking a break now for a moment. So we'll be back in about 25 minutes. So I encourage you to come back because we have 3 more great talks on track 2, and then we obviously have more again on track 1 later on as well. We have Andre Urban talking about the web development or web scraping stack. We have Nikki talking about COVID Snap, and we have Wes as well talking about data for classification. So we also have competitions as well, where we're going to be giving away kind of vouchers, learning credits, and Boss headphones, and I think Lego as well. So we'll be doing a draw for that later on. So yeah, you can guys grab a coffee, breakfast, dinner, supper, depending where you are, whatever you need. And we'll see you in about 20 minutes, 25 minutes. Thanks, everybody. Okay, welcome back, everybody. Thanks for staying on. So we're into our next section. We have another 3 talks to go on this track, and then you can join over to watch the remainder of track 1. So our next talk is Andre Urban. He's a technical web expert at Apify. Andre is a hacker of the browser edge. He extracts terabytes of publicly available data and translates them into a language that machines can understand. He leads a team of fellow hackers who grow their open source projects and break anti-scripting walls and dabble in AI. So Andre is going to be talking to you today about the web scraping tech stack for 2020 and beyond. So Andre, do you want to say anything before we get started with your talk, or are you happy with me to go?
Yeah, sure. Thanks, Colm, for the introduction. I just wanted to say hello, everybody. And this talk is really just an overview of what's available currently in the web scraping environment. So if you have any questions about any of the things, because I don't really get very deep into the particular topics, I really just, flow over all the different kinds of technologies and things. So please ask questions. I will happily answer them at the end of the talk. That's all I wanted to say. Thank you.
Great. Okay, so we'll get to it now.
Hello, everyone, and welcome to my talk on web scraping tech stack in 2020. The internet has changed a lot in the past few years, and so did web scraping. Extracting web data at scale is becoming increasingly difficult. Web applications are complex, dynamic, and often employ several layers of protection against automated access. This talk will not give you a cookie-cutter strategy to scrape any website, but it will show you the latest tools and technology that will significantly improve your chances of creating reliable and scalable scrapers. My name is Ondra Urban, and I'm the lead maintainer of Apify SDK, which, according to GitHub, is the most popular web scraping library for JavaScript. Apify is a web scraping and automation platform, and we scrape billions of pages every month for small businesses and Fortune 500 companies. Besides leading a team of engineers, I'm also an architect of our enterprise-grade scraping solutions. Before we start, let me ask you a question. What is web scraping? When you search on Google for web scraping tutorial, most of the results will teach you how to download HTML and extract information from it. It works, but hardly scratches the surface. It's like making a microwave-ready meal and calling it cooking. Technically, it's correct, but it gives you the wrong impression of what cooking actually is. Do you know Hacker News? It's a popular technology news site, and only a few days ago, people there were discussing web scraping. What do you think they talked about the most? Which tool they use to parse HTML? In our experience, HTML parsing is only a small part of the web scraping problem, both in terms of complexity and the time consumption. So what are the hard parts? Downloading 1,000 pages a day instead of 10, and then 1,000,000 instead of 1,000. Keeping your scrapers reliable and up to date. Any website update can potentially break your scraper. You also have to overcome clever anti-scraping systems, guarantee perfect quality of data, and last but not least, you must be able to do all of this at a price that is acceptable for both you and your client. Okay, enough talk. Let's finally scrape something. The obvious thing to do first is to download the page's HTML. Let's look at how we might do that. Sure, we can make a simple HTTP request to fetch the page's HTML, right? We tried that for Amazon.com, and surprise, it did not work. To discuss automated access to Amazon data, please blah blah blah, we got blocked on our first request. Why? Because Amazon and most of the other major internet players use request header analysis to detect automated traffic. What can we do now? Well, we can add the correct headers. For Amazon, adding the user agent header will be enough to get you going, but other websites are much stricter in their checks. Some check for specific header values, others enforce correct character casing. Fortunately, there is a simple way to avoid all those problems, and that is emulation of browser headers. The purpose of all bot detection software is to block bots, but at the same time, humans must not be blocked. Emulation of browser headers from a publicly used browser, such as Chrome or Firefox, allows us to disguise our scrapers as human users. There's one very important detail though. Never mix up the headers. There are tiny differences between headers used by different browsers and their versions. To have the best disguise, find the set of headers used by a specific browser version and use all of those together. Now that we know how to fetch a page's HTML, we can start crawling. Crawling, or spidering, is the process of collecting links from websites, and it has challenges of its own. Before we start collecting links, we need a place to store them. This is easy for short-lived crawls, but once you need to crawl millions of pages, you'll save yourself a lot of headache if you use a proper request queue. Here are the 4 key features that it must have to serve a wide variety of scraping scenarios. First, it needs to be dynamic. You need to be able to add and remove requests from the queue as you open pages and find more links. Second, it needs to make sure that the links are unique and not just equal, but pointing to the same resource. This means it needs to normalize the URLs by reordering parameters, removing fragments, and so on. Third, it must be persistent. You don't want to lose your progress in a long crawl when your crawler suddenly crashes. And finally, you must be able to store extra information with the URLs, such as login credentials, crawling state, and partial results. Okay, great. We have a place to store our links. Let's look at collecting them. On one hand, collecting links is a pretty boring process, so you want to automate as much as you can. On the other hand, you can't just grab everything the internet throws at you. The best way to go about this is to use the structure of the website to guide you. Are you looking for product links? Find the product elements and only grab links from those. Do you want to do a full domain crawl? Okay, find all links, but limit them to the domain you're interested in. A good tool will let you easily apply those filters and will deal with the extraction itself for you. Could this tool also enforce uniqueness of the links? Yes, but no. To ensure reliability and consistency, it would need to keep a cache of links it already found. Essentially, its own mini request queue. There's one pretty big challenge in finding links though. Most websites still use HTML href attributes for navigation, but the number of JavaScript links is quickly increasing. What is a JavaScript link? Typically a link that is created dynamically once a user clicks a button. Why is that a problem? Because you can't really parse this link from HTML. It's not there. To get the link, you need to simulate a user clicking the button. And for that, you need a JavaScript rendering engine. I'm sure you noticed that sometimes a website works correctly in one browser and not in the other. That's mostly because of differences in their rendering engines. Long story short, to reliably extract JavaScript links, you need a browser. This brings yet another host of challenges though. Clicking 100 times a second in a web page to extract links is not something browsers and websites were made for, and they need a bit of convincing to do that. We've covered the basics of scraping and crawling. The previous concepts give you a great baseline for extracting data from the internet. For personal and small projects, you probably don't need much more. But if you want to learn how to scale your project from 1,000 pages to 1,000,000 without a major headache, bear with me. Okay, so the first and most important aspect of scraping at scale is using the right set of tools. Yes, you can find a library to do your HTTP requests, an HTML parser, put all your URLs in an array and write a for loop to iterate over them. Yeah, sure. But what about errors? A network error or a parsing error should not crash your scraper. So you implement a retry system. Then you find out you need to scrape faster and you add parallelization. But then your scraper runs out of memory, crashes, and you need to start scraping from the beginning. So you add a database to manage your requests. Slowly but surely, you implement everything we talked about so far, and you spend 90% of your time solving generic problems instead of focusing on the data you need. It does not matter if you prefer JavaScript or Python. Always use a good scraping library like Epify SDK or Scrapy. It will save you tons of work and stress. Okay, so we have our great, fast, reliable scraper. We have millions of links to crawl, and after 100 or so, our website sends us nothing but rate limit or authorization errors. It's time to use a proxy server to split the load over many IP addresses. This is pretty obvious to those familiar with web scraping. What people often don't realize is how many different proxy servers there are and how to best utilize them. The most basic proxy server is a data center proxy. They are cheap, fast, reliable, and the easiest to detect. The exact opposite are residential proxies. Leveraging real users' devices and a huge range of IP addresses, they are very hard to detect. On the other hand, residential proxies are very expensive, often slow and unreliable, because the user can lose internet connection or turn off their device at any time. There are also specialized proxies, such as Google Search proxies, which deliver Google search results and nothing else, super proxies, which are services that automatically manage proxy rotation and traffic for you, and many more. You should add all of those to your toolkit and use the most appropriate ones for your project. After a very brief overview, let's look at some practical tips on how to get the most out of your proxies. The best way to keep your proxies healthy and useful is to behave like a real user would. That is, keeping a consistent profile. When you visit a website, it assigns an identifier to you, typically a browser cookie. Now, what do you think would happen if this website received this identifier from Canada and half a second later the same identifier from Germany? Right. This bot detection system would ban both IP addresses because so far, people and their computers don't teleport over the Atlantic. A set of identifiers is called a session, and once you get one, you should always use it with the same IP address to look like a real user. A practical thing is to pre-build your sessions before the actual scrape by visiting a website from multiple proxy servers and assigning your sessions to those servers. A very practical thing is to have a tool that does that for you automatically, like the session pool of Apify SDK. I mentioned that residential proxies are expensive, and that's because they are generally charged per consumed traffic and not per IP address, like data center proxies. Fortunately, there's a trick to reduce your proxy costs by a significant amount, and that is routing only the important requests through residential proxies. Imagine you needed a residential proxy to load example.com in your browser, but example.com also loads various uninteresting but required assets like JavaScript files, images, ads, tracking tools, and whatnot. Unfortunately, you can only assign one proxy to your browser, so all those requests go through the residential proxy, significantly increasing your cost. What we do is connect the browser to a dummy proxy server of our own and send only the important requests to the residential proxy. Through some trial and error in finding what the important requests are, we're able to reduce our proxy costs by up to 90% and speed up our scrapes, all while staying hard to detect. Even though it may seem that with a large enough proxy pool you can scrape almost anything, it's no longer the case. Bot detection systems are very sophisticated these days and operate in several layers. They analyze your network requests, ban you if you don't render JavaScript, and collect hundreds of data points about your scraper to find if you're a bot or a real user. In such a case, there's nothing you can do but pull the most powerful and expensive trick in your arsenal, the headless browser. Why do we need a browser? Well, at a very basic level, we need to reliably render JavaScript. Modern web applications are built with tens of thousands of lines of JavaScript, and without it, they don't work at all. This does not mean that from now on, you need to use a browser for everything. You don't. But you need to have it ready in your pocket. An important aspect of using a browser is that it allows you to emulate real user behavior. Without it, some websites just cannot be scraped. The next use case is web automation and RPA. To automate human processes and workflows, you need to be able to emulate human actions. Puppeteer was the first mainstream library that gave you full control of a real browser, while also allowing you to run it headless. That is, without needing a display. It uses the DivTools protocol of Chromium and Chrome and allows you to control all features of the browser, even those inaccessible to users, such as the network layer. This is a big upgrade over Selenium, which has a limited feature set. With Puppeteer, you can drag mouse and click like a real user would, intercept network communication, inject your own data, or prevent requests from being sent at all. It is a JavaScript library. There is a community-built Python version, but it's not very popular. Playwright, on the other hand, could also be called how Puppeteer should have been done in the first place. It's built by engineers who left Google and the Puppeteer project and joined Microsoft to build a new, better version of Puppeteer. Its most important feature is that it can control not only Chromium-based browsers, but also Firefox and Safari, giving you a much greater toolkit for scraping almost any website. Good news for Python users is that unlike Puppeteer, it has first-class Python support. If you've never used a headless browser, you should choose Playwright today. But note that it's still far less popular and stable than Puppeteer, so tutorials and examples may be hard to find. Good news is that the interface of Playwright is largely the same as Puppeteer's, so switching from one to the other should not be complicated, and Puppeteer supports Firefox nowadays too. While discussing browsers, we should talk a bit about fingerprinting. A fingerprint is any information that a website can collect about you and later use to identify you again, even when visiting a different website. It's a practice widely used by bot detection software and online advertisement providers. When using plain HTTP requests, the website will collect your IP, user agent, headers, TLS version, and other markers. When using a browser, it will also collect information about your computer, what operating system do you use, how fast do you download and render images, what video and audio hardware you have, what browser extensions do you use, and so on. This is a huge problem from a privacy standpoint, but it also makes scraping more difficult, because even if you change your IP via a proxy server, the website still sees you as the same user and will act accordingly. How to combat this? You need the browser library powerful enough to let you emulate the fingerprints of real browsers running on real computers and pair those fingerprints with your user sessions. Remember session pool? The default settings sadly won't get you far. Okay, I would like to shortly mention a new tool which got published only a few months ago. Its name is Secret Agent, and it's a browser manipulation library that focuses on being undetectable, or, in other words, having the right fingerprints to pass any bot check. It's still in the early stages of development and does not provide comprehensive features as Puppeteer and Playwright do. On the other hand, it might help you in cases where avoiding bot detection is paramount, such as web automation and RPA projects. So far, we've covered all the tools you can use to create reliable and scalable scrapers or web automation robots. In this last section of the presentation, I would like to give you some ideas on how to use those tools to build performant and cost-effective solutions. API scraping is probably the most effective way of extracting data from a website. Most websites use public APIs, so all you need to do is open your DevTools, look into the Network tab, and do a little detective work to understand how the website's front end gets its data. Once you find the data you need, it's often easy to reconstruct the requests and never parse HTML again. Some websites require you to have a session before allowing you to access the data. You can use a headless browser to create the session and then proceed to access the API. When the session expires, just refresh it again with the browser. Scraping APIs is really the best kind of web scraping because reverse engineering APIs is fun, it reduces load on the website itself, and it tends to be really fast and cheap. You should always check for that opportunity when you can. Mobile apps are often purely API driven. This means they don't bother with HTML and get their content exclusively from APIs. This is a great time to use API scraping, but there's a problem. We don't have any dev tools to reverse engineer the network communication. Fortunately, there is a way. By installing a custom certificate to your phone and a man-in-the-middle proxy to your computer, you can inspect the mobile app traffic just as you would inspect it in DevTools. After understanding the communication, you can easily fetch the data. Note that we're getting into a legal gray area here, so make sure to always consult the application terms of use and applicable law before scraping data using this approach. Finally, the last technique, which can help you significantly cut the costs and increase the speed of scrapes. We start with a website that uses some bot detection system that requires you to solve a challenge before you can use the website. This is typically some JavaScript that it expects the client to evaluate, and based on the result, it either allows access to the website or prevents it. We start by requesting the website's content using a simple HTTP request. The website responds with HTML that includes the challenge, but no data. Luckily, we have a real browser with a good fingerprint running in the background. We send the challenge to the browser, and the browser evaluates it. The problem is, part of the challenge is also sending the result back to the website. But we can't allow that, because the website would see the response came over a different network connection, a different socket, and block us. So we use our browser library to intercept the response and send it to our HTTP crawler instead. Now we can send it back to the website over the same connection. The website is happy with the result and finally sends us the content we were looking for. Why is this black magic useful? Because more often than not, once you're allowed to enter the website, you can stay there for a while. After a few requests, you'll have to complete the challenge again, but that's okay. Instead of using a browser for 100% of requests, you can use it only for 10%. Saving money and making more kinds of projects commercially viable. And that's it. Both web scraping beginners and professionals learned something by watching this presentation. And if you have any questions or comments, please let me know in the following QA or send me an email to ondra@appify.com. Thank you for your time and have fun scraping.
Thanks, Andre. That was excellent. Some really good tips there for modern day web scraping. So I think we have a couple of questions here in the Q&A. Jessica says, what kind of tool do you recommend to, I'm not sure what that is.
Yeah, it's ASPX.NET
Yeah.
and the Ajax
Yeah.
site. Yeah, basically how .NET sites typically work is they navigate through post requests. So this kind of what it does, it reloads the website the moment you click on the link. It like sends you to a different kind of website, to a different document. This can be emulated with basic HTTP requests, but you need to really analyze the post request. You need to look at how this works and look at what data the post requests are sending, which can often be quite daunting to kind of go through all this kind of information and just reconstruct all the different responses. Oftentimes they have some encrypted data or just they are not easily readable. So what we often do for ASPX sites, if it's not limiting to if it's not limiting money-wise or cost-wise to the clients or to us, is we use a Puppeteer or any other browser library that you prefer to kind of extract the links and extract the specific requests, and then when we intercept them, we use them in our HTTP crawlers. I'll give you an example. You have this kind of website and you want to scrape a listing there. It has 10 pages of listings. You get to the first page, then you need to click on the second link to get to the next page, which actually triggers all this kinds of post request stuff. So what we would do with the Puppeteer or with the browser, we would do all those clicks, we would collect all those requests, we would know how the requests work, and then to scrape all the data, we would use an HTTP crawler, basically avoiding the browser to save cost. So let's say we call it pagination. So if you have, 20 pages of results, but each page has 1,000 results, we would only do the 20 requests from the browser, collect the information about the requests, and then use the HTTP crawler or any kind of, how you want to call it, to scrape all the different results from those pages.
Cool. Great. Then another question here. I'm not sure if you can see them, Andre, but I can read them out just in case the attendees want to hear them. But why did you create your own SDK when you could have used some open source framework? What are the pros and cons of your approach?
Yeah, well, I think at the beginning we just worked with JavaScript and wanted something that works with JavaScript. We just at Appify, we feel that when you're scraping websites which are written in JavaScript, then it totally makes sense to be scraping them in JavaScript. It just you don't have to do this context switching. That's one thing. And on the other hand, at the moment that we were starting, we just felt that the tooling and everything was really starting to step up in the JavaScript world. Puppeteer was just launched, and we were seeing some great progress in some other libraries and stuff. So it felt like it's the new space that we could actually go to and create something new. Because obviously, I mean, for Python, we already have great scraping libraries, and maybe for other languages too. I don't know. So we just decided to go this way.
Great. And then, how do you solve the JavaScript challenges? Or sorry, do you solve some JavaScript challenges manually, or do you use only browsers for that?
Yeah, I mean, obviously doing it manually is not very effective. So we tend to use browsers for everything that requires some high level of challenge solving. But I must say that there are human solving services, and that's when you hit CAPTCHAs, because some kinds of CAPTCHAs are really difficult to solve for machines. And there's always a hack that somebody comes up with, but then it gets fixed a month later, so it's not very reliable to use. And but there are services that basically can use humans to solve your CAPTCHAs for you. So if your robot encounters a CAPTCHA, it can send a request to an API, and then at the other end of the API, there's a human who will actually solve the CAPTCHA for you, and you will then be able to allow to proceed with the scraping. So this is something that in projects were required. Yeah, we use that.
Okay. Then not all only browsers can render JavaScript. There are some rendering engines like JSDOM. Have you tried any of those?
We were playing with JSDOM a bit. We just feel that it doesn't really add that much of a benefit to use a rendering engine that's not a real browser, because that comes up with other different challenges, like not being the rendering engines that people use, and we always look like real humans. So for some cases, it can be more performant, because obviously running a browser versus running a simple small rendering engine is very, much more cost effective. Well, much less actually than running a browser, but it's not as powerful. So it's something that's somewhere in between the HTTP requests and browsers, but we really just go either with one or the other, and not really with something in between.
Great. And then Magna asks Puppeteer versus Splash.
That's a good question. I don't have any experience whatsoever with Splash. I can't code Python, only like very simple things. So I have no idea, to be honest. But I know that Splash is a custom built browser, basically for scraping. So just my gut feeling is that given all the fingerprinting, all the ways the bot detection systems and browsers behave nowadays, and it would be easier to detect than full Chrome or full Firefox. On the other hand, it's probably more lightweight. So again, this is probably something in between having a full Chrome versus JSDOM. So it sits somewhere there, and I believe that it has a lot of applications. I just don't have any experience with it myself.
Great. We probably have room for one or two more. What's your strategy to tackle JavaScript fingerprinting in the browser? Did you encounter some challenges with the scaling?
Yeah, well, most of the time, we just try to make the browser look as good as possible using some techniques, some typical things that the anti-bot systems look for. But for the very sophisticated tools, this obviously is not enough, and you need to go deeper. So what we would do in those cases is that an engineer would actually, look specifically at that website. They would deconstruct it. They would look at all the different JavaScript commands and functions that are being called in the context. They would see what the website is trying to fingerprint, actually, to see, hey, are they looking for, my viewport size? Are they looking for what graphics card am I using? Are they looking for what OS am I running? Typically, they do for all of those things. And then once we know what they are actually looking for, because obviously we are running the browser, so we control the environment. So it's possible to read all this information from the JavaScript that's being sent to us. And once we know that, we can kind of reverse engineer it and create our own fingerprint that matches what they want to know. So instead of using the default that's available with Puppeteer or Playwright, we inject our own values about, graphics cards and processors, memories, displays, I don't know, whatnot, and create a simulation of some computer that actually exists in the real world. And if we create enough of those simulations of computers that exist in the real world, we can create enough sessions to actually scale it up.
Cool. How do you create those browser fingerprints?
Yeah, we don't really create them. It's more like collecting them from all over the internet. There are places where you can, get those fingerprints. We obviously don't care about any personal data at all, so because that's really not useful to us. So we don't collect any personal data anywhere. Because really, if you create the fingerprints, you have a chance of doing it wrong. And if you do it wrong, you will get blocked. But if you collect them, and you collect enough of those fingerprints, hey, those are actual users, then you know that you will be successful with those fingerprints. Obviously, you can't use them that much. You need to have a big pool of those fingerprints. But especially for the web automation tasks I was mentioning, where you really just need to simulate one user, because this one user needs to log somewhere and do some job. It's not about scraping millions of pages. Then those fingerprints are extremely useful because they really allow you to get through the anti-bot systems, where really you aren't a bot anywhere. You're just some person trying to not have to do stuff manually. So
cool. Okay, cool. That's great. I think there's some great questions there. If any more pop up, you can, if you have time, you can answer them or we can forward them on to you. But we're going to move on to our next talk now. So our next talk is Nikki Tetamanti, and she's going to be presenting about web scraping for real-time surveillance of food security policies during COVID-19. So obviously COVID-19 is a pretty big thing this year. It's the reason we have a virtual event. So obviously there's going to be a talk on it. Nikki is a student at the Columbia University of Public Health. She's interested in how the social world determines health outcomes, specifically she studies the relationships between gender, sexuality, occupation, and legal structures with different health outcomes. She's editor-in-chief of Intervene Upstream, a public health publication for graduate students, and she was a team lead for the COVID SNAP project. So Nikki, I think she's on now. Do you want to say anything before we go into your talk, or would you like me to just go ahead?
No, you can just go ahead. That was a wonderful intro, Colm. Thank you.
No problem. Okay.
Hi, my name is Nikki Tetamanti. I am a master's in public health student studying epidemiology at Columbia University Mailman School of Public Health. This summer, myself, along with many others at Columbia Mailman School of Public Health, additional volunteers and some from University of Miami Miller School of Medicine, conducted a project where we were trying to understand the variation in different food security policies in real time during the COVID pandemic. The PI of this project was Dr. Sari Abiola at Columbia University Mailman School of Public Health. And today I just want to be talking about the web scraping portion of what we did. So web scraping for real-time surveillance of food security policies during COVID-19. You may be here because you're interested in food security policies. You may be interested in using web scraping for policy surveillance, or you may just not really know much about how these two fields could intersect in a time of great public health need. And so I'm here to present on all of those things and definitely open for questions. This is a different kind of format for doing a presentation, but my email will be at the end of the presentation. You can email me or Dr. Abiola about our work. And today what we're going to be going over are the COVID-19 food insecurity in the food stamp program, or the SNAP program is what it's called now. We're going to talk about policy surveillance and web scraping, different approaches that I use for web scraping, including R versus Python, and I'm going to be comparing these approaches. Then I'll be discussing what advantages Scraping Hub provided, and finally the use cases and results of our data set we produced. So first, let's talk about a little bit of the background. What's going on now in relation to COVID-19 food insecurity in the SNAP program? Due to COVID, there's a lot of job loss and school closures, which really increased the threat of hunger and food insecurity among people in the United States. If we look at the projections of food insecurity among the population across different US states, you'll notice that many states have over 20% of people in the state experiencing food insecurity. This is a projected rate, and so it wasn't the actual rate. This projection was made in May of 2020 by Feeding America, one of the foremost, or the forerunners in thinking and writing about food insecurity policy in the United States. And this just demonstrates how when there's unemployment and school closures, a lot of ways people receive food becomes limited as a result of limited income or not being able to access congregate feeding areas in schools. And so there's a lot of need in relation to improving food security during this pandemic. This was a couple different scenarios that were outlined. So on the x-axis, you see the year, and the y-axis, you see the number of food insecure individuals. So as you'll see in 2008 to 2014-ish, it was pretty steady around almost 50 million people. And then we see a sharp decline from 2014 to 2018, where around, between like 37 million people were food insecure. And now we have to make projections of how many people we think are going to be food insecure. So Feeding America performed these projections under scenario C, where we might experience really high rates of unemployment, like 7.6%. We might see upwards of 55 million people being food insecure in the United States. Currently, unemployment is at around 7.9%. And so we can probably estimate that there's a large and growing number of people across the country who are experiencing food insecurity. Part of combating food insecurity involves federal programs which allow individuals who are low income to receive monthly benefits on a debit card, which can be used to purchase food in stores. This is called the SNAP program. It used to be called the Food Stamps program, and it's run by the USDA, and it's run by the Food Nutrition Service within the USDA of the federal government. And it's probably the main program we have here. If you look at this map here, you'll see that between a little bit less than 8 to over 16% of people in each state participate in the food stamp program. And so that's quite a sizable proportion of people who we can actually target and actually get increased access to food, although the benefits usually often aren't enough. And also there is kind of more need than the benefits allow. A lot of people may not actually qualify for food stamps, but still be in that food insecure group. And what happens is the federal government and the USDA generally sets different policies, and the state governments actually implement the food stamp policy. And so this SNAP program is administered on the state level through state departments of Health and Human Services and different departments that engage in the social welfare administration in each state. So the state actually implements the programs that the federal government sets the policy for those programs. But when there are emergency situations such as COVID, there's a reason that, or there's not a reason, but there's basically a need for the policies to be a little bit more malleable and shift. And so what ends up happening is that state governments can then request waivers to change policy, and the federal government can approve or deny those waivers as need be. For instance, a lot of college students, it's really hard to get food stamps. If you're a college student, you need to work above 20 hours. And so what ends up happening is that a lot of these states may request a waiver as a result of, say, COVID-19 to allow them to give food stamps to college students without that requirement. So the USDA can approve or deny these waivers in the case of the giving increased food benefits and decreasing the eligibility requirements for college students. That was a denied waiver. Many states applied, but was ultimately denied by the USDA. But essentially, I just want to get across that there's a lot of variation here because each state can kind of request different types of waivers to change their policy, and the federal government can approve or deny or kind of modify those waivers as it sees fit. Each state could opt in or request waivers to increase access to SNAP. And since each state kind of acts independently, there could be a lot of variation in policy state by state. Nevada could apply for all of the waivers. Meanwhile, Utah could apply for none of them. And understanding this variation can really help us understand what policy levers might influence the SNAP program enrollment and food security, because we can actually test out and see how different combinations of waivers influence program enrollment, monthly program enrollment data, and things like this. And we can actually maybe gauge the impact in a quantitative way, although of course mixed methods and actually interviewing different social workers on the state level might be another approach that someone might take. Which leads us to the question of policy surveillance and web scraping. Basically, knowing that there's going to be a lot of variation, we wanted to know the detailed information of at least 10 different waivers across 50 states, and we wanted to track this information as the pandemic progressed. But we were all a volunteer team with limited times on our hand to hand code information, and hand coding can be pretty error prone. We did have to eventually hand code other information that we needed out of PDFs, but initially we wanted a way to gather all of this data all at once in a quick and easy way. So the question really is, how do we take this data, which this is kind of what the website looks like, the federal government website that tracks all of these extensions and waivers. So how do we take this data that is in a very, a format that's easy to understand and easy to navigate to if you're looking specifically for state level information, but isn't at all a data set, isn't at all something that's a table? How do we turn this information into this, something that's a usable table for research, something that we can actually use to make analysis about the variation and analysis about maybe how these different policies are going to be influencing food security. So that led us to look into web scraping to turn websites into structured data. Basically, we had to identify the source of the data, which was the Food and Nutrition Service website for COVID-19 waivers. We had to extract state level data about which waivers each state applied for, whether or not the waivers were accepted, and other information such as the date the waivers were requested or the date the decision was made. We had to extract the actual data from the state website, and then we had to standardize and compile the data in cleanup. So we had a 5-pronged approach to be able to do this. The first one was to identify the set of URLs to scrape. The second was to determine what data actually needed to be extracted from each website. The third was to inspect the HTML of the identified data. Fourth was to develop code to actually extract the data, and 5, to export that data to a usable format. The first 3 steps are going to be kind of done regardless of what kind of software package we were going to decide to do. But the 4th step really requires us to determine how are we going to develop it, which tools are we going to use, and we'll talk about that a little bit later. But the first step was to identify the set of URLs to scrape. So each state had a splash page. We noticed that the URL for each state was, which is listed here in the bottom left, just included the /COVID-19/ the state name. And you could replace the state name with any of the states with, if the state had a space in it, we put a hyphen between the names. And that really gives us a list of all of the URLs we need to scrape. Then we need to determine which information actually needs to be extracted from each of these web pages. There was a lot of different tables because there's a lot of different federal programs that have different waivers and flexibilities, but we were only interested in one of these 4 programs. So we wanted to extract this first table, the Supplemental Nutrition Assistance Program table, and we wanted to know the date, the request, and the status, as well as any additional information such as the data was received, whether there was an extension, really any amount of information from this table we wanted to keep. And regardless of which state it was, the SNAP table was always the first table, which made our job pretty easy. Then we had to inspect the HTML of the identified data. So I was using Chrome and I went to More Tools, Developer Tools Selector, and was able to select out the table and really get the XPath to the data. And so if you'll notice, the last part of that XPath is table *1 and what that is, it means it's just the first table in the web page. And so we were able to basically get the first table, which was always the Supplemental Nutrition Assistance Program. So we know all the URLs, we know we want to always scrape table 1, and we know table 1 is always going to have this XPath, which gets us in a pretty good position to be able to actually scrape the data over time. The 4th step was actually develop the code to extract the data. And first, what we did was used R and Arvest. And Arvest is basically a library that lets users easily scrape and harvest data from web pages. It's part of the tidyverse set of packages in the R universe, which is designed for data science. And it's most similar to the Beautiful Soup library in Python, though I've never used Beautiful Soup. That was the first approach just because I was more familiar with R than I am with Python, and I figured might as well get started that way. When we used R, I created a main scraping function. And so what this did was basically go to the state's web page, and there's actually a built-in core package inside of R that lets you just type in state.name and state_number, or really just the state name and the state number. There's a function of all the different states. And so we could take that initial URL that we identified, we can append the state name to it, and then we can just send that along to the read HTML function that gives us the web page table. We save that first table as the snap table variable by using the rvest HTML table function. And if you notice, there's the 1 at the end of it. That was our first table. I could change that to 2 or 3 or 4 to get the subsequent tables on the web page, but because we were only interested in the snap program, that stays as 1. Then all of the rows are captured. We figure out how many rows there are on the snap table. And then for each, so that's basically the main scraping function. We also need to create a data frame to store the extracted data. And so this just has the data proof, the request, the status, and the jurisdiction. And that's all in a data frame called full data. And then we need to loop through the states and actually export each part of those rows to the data frame to be able to export the data frame then to Excel to make it usable. This is a really big mess of code because there was some issue. Basically, I would run the code. There would be some states that are missing. There would be disconnections and timing out on the server. Sometimes the server would block our requests. And so really and truly, all of this additional information that's in red was a lot more simple, but I was sourcing the web to try to figure out ways to prevent these issues from happening, such as making the system go to sleep when it throws an error, having more time between scraping a state, closing the connection before restarting it. All of these things didn't really fix what was going on. Truly, we weren't able to scrape with R and rvest, and it got to the point where I couldn't make sure that data was reliable. And so, I don't want to give out bad data about the food, about the different waivers that were available, and so we needed to find a different approach. The second approach was using Scrappy and Python, which is an open source collaborative framework for extracting data in a fast yet extensible way. As you know, it's maintained by Scraping Hub and other contributors. And our approach was pretty much the same. We needed to store all URLs for each state in a Scrappy spider object. So the spider here, we call it the waiver spider. The allowed domains were the food and nutrition service, and we have all of these start URLs here that I had actually hand-coded. It's probably an easier way to do this, but I wanted to make sure that we had a comprehensive list of all of the states. All of them have the proper formatting, and really it was the easiest way for me to do it quickly. This lets us list all of the URLs that the spider is going to be going through. Then we need to store the fields for the scraped objects in a Scrappy item object. And so that's very similar to R and rvest, the data frame we made. Basically, this is an item called FNS item. It has the program, which is snap, the jurisdiction, which is the different states, the date, and then a couple different fields for the requests and the statuses. And then we actually need to parse the data. So we need to pull the snap table from the URL using the XPath that we had previously identified, loop through each row of the table, and then store the results into an item. So this first part actually goes to the XPath of the whatever URL is being parsed that the spider is parsing. And then we loop through each row of the table that we had, and we're basically just saving all those different parts. There's some additional pieces to these XPaths, and so we had to actually find out which row corresponded to which item, whether that was the row for the date, the row for the request, the date received. There's a lot of trial and error in identifying these, but eventually we got to a point where we could capture most of the data we needed. But there were the same issues. We were missing data on some states due to timing out and being disconnected from the server. and the connection will be blocked for some time. So we tried a couple different things, changing some settings, like disabling cookies and enabling auto throttle. Those are two key suggestions, but we still had some issues in being able to actually scrape the data. So we decided to ask for help. We reached out to Scraping Hub for their assistance, and they generously provided our all-volunteer team with a premium Scrappy Cloud account. I pushed the code to GitHub from PyCharm. I connected the repo to Scrappy Cloud, and I ran the code, and basically successfully was able to export the data to an Excel table very quickly. All of those problems that I had run into with R and RVest and Python and Scrappy when running it on my local machine were completely alleviated. There weren't any errors thrown, and a later validation of this data, we had two research assistants basically go in and look at 10% of all the waivers that were randomly selected to make sure that they appeared on the state splash pages. And then we also checked 10% of the states, so we had them basically go to every state page and make sure every waiver in that state page was listed in this table. So both of them produced on 100% results. All of the waivers were there. All of the states' waivers were there. It was really good news to see for us. And what are the uses for the data, and what are we kind of learning about it? One of the uses that our data set gives is basically understanding variation in these different food security policies. So this is just an ArcGIS map. There's going to be a link at the end, so it's static right now, but essentially this is a map describing waiver activity. So the darker the state, the more waivers that state had applied for and gotten accepted. It could be a proxy for something like how active and how aggressive is a state in trying to get waivers. That's what we initially thought, but there's also a lot of states that just don't get waivers because there's increased regulatory or administrative burdens that could be associated with it, and they just may not have the staff to be able to do it. So but we can see here that there is variation within waiver activity. There's also the ability to link this to state level data sets, because we have a data set that goes through time and has a collection of all these waivers. We can actually go and get data such as this table. This table basically is describing the number of persons participating in the SNAP program in April 2019, March 2020, and April 2020. And then there's also the percent change in number of enrollees between April 2020 versus March 2020, or April 2020 versus April 2019. And so what we can do, and this analysis isn't perfect, but essentially what I've done is highlighted the row that compares the percent change between April and March, which I would suggest is when you're going to see a bulk of new participants coming in is probably April. And basically, you can do something like a linear regression of the total number of waivers onto the percent change in program enrollees in SNAP, and we find that the number of waivers a state applied for is not a significant predictor of percent change in enrollment. This isn't an analysis that's completely robust. It's just an example of a potential use case for this type of data. And so, don't take this as complete fact, but it's definitely the beginnings of exploring how these different waivers and policies really interact to influence food security. And in conclusion, web scraping can be an important tool in policy surveillance, especially during emergencies where data may not be structured well. The Food and Nutrition Service was definitely updating their website often, but it wasn't always formatted in a way that was quite clear. And actually, a couple months into the pandemic, they changed the form of their website. And so the web scraping tool actually had to be changed later. So that's one disadvantage of using web scraping, is that if the tables or the HTML changes on the website, you're going to have to change your code as well. But it can be an important tool because it can do things really quickly and accurately. The second takeaway was that Python and Scrappy was more flexible to develop than R and RVest. It just seemed like it worked a little bit better and was a lot more comprehensive, and kind of had a little bit of a bigger learning curve, but ultimately that learning curve proved useful because we were able to integrate this platform with Scraping Hub and Scrappy Cloud, which bypassed previous limitations with running the spiders locally. So we were able to actually fully be able to get the data we needed with the support of Scraping Hub. And this is a shout out to all the people on the team and what their different roles were. And we had a group of people help from the No Brand and Her network, as well as different academics who helped us early on in dataset development. And if you have any questions, you can email me or Dr. Sarah Abiola. You can also download our dataset. There's the Open Science Foundation, our link there to the project that you can download it. We have it all released publicly, or you can go to covidsnap.org. And if you have any questions, just feel free to reach out. I would love to chat about everything. Thank you so much. Bye.
Thank you, Nikki. That was a great talk. So yeah, that was really interesting. Does anybody have any questions on that topic? I actually have one. At the end there, you mentioned how web scraping could be used in policy surveillance. Have you guys any future projects in mind for that, or any previous ones even?
Yeah, no, it's a really good question. I think, there's a lot of organizations that do track laws in a lot more of a robust way because they have teams of lawyers or teams of policy analysts doing the manual collection of laws. And so I think for projects that involve things that a lot of people care about, those types of teams are probably going to be continually the ones doing that work because they need to do a lot of checking to make sure that the laws are valid, that they're coding and things like this. But I think for projects that are a little bit smaller, where maybe there's less policy attention being paid to them, web scraping is a really great tool. So, for this food stamp project, there's a lot of food scientists, food policy researchers, but it doesn't have the same kind of level of attention as some other issues. And so those types of projects are really well suited, I think, for policy surveillance with web scraping. As far as future plans, I think that there's, we want to kind of see if there's a way to maybe streamline what we're doing now. One of the issues was that the Food and Nutrition Service changed their website midway through. And so it's good because it reflected kind of a more updated and easier to read format for those researchers. So part of our role was kind of that stopgap of there's all this information, how do we understand it in real time? But now it's almost like eventually the tools that these other organizations create are going to be a little bit more robust, hopefully. So I think we might continue doing a little bit of web scraping with the Food and Nutrition Service, but I don't think that there's a project kind of waiting as far as what we're going to do next. But there's definitely a lot of different variation in a lot of legal data and in policy data, and especially with COVID, it really brings forth this state by state variation because each state's response can be so radically different from another state that it really could be a useful tool that a lot of people could use for COVID type legal research.
Cool. There's another question. To analyze the data, did you stay in Python or did you go back to R?
Yeah, that's a good question. I think that's from Juan. So yeah, we basically started in, like I mentioned, started the scraping in R and then eventually moved to Python to do the scraping. But as far as the actual kind of basic analysis that we've been producing, that's been in Stata. We had someone working in ArcGIS using kind of just an Excel output from a different piece of the project that we are working on, or a kind of an offshoot data set we produced from this web scraping one. So yeah, basically we use a lot of different tools to analyze the data once we get it, and R hasn't always been the preferred tool to use, and mainly other programs like Stata, they give you just a lot easier, it's a lot easier to run some of these analyses with the graphical user interface, and you still maintain some control because you can always create a do file and things like this. And so yeah, we've been using Stata a lot for the actual analysis.
Cool. Gregory says, you did a lot of HTML scraping. Did you see whether the API was available to scrape via Google Dev Tools?
No, I didn't. When I was looking through, when you say the API was available, do you mean an API produced by maybe the Food and Nutrition Service, or something different than that?
Maybe Gregory, you can clarify that.
I'll be honest here. So I'm pretty new to the web scraping, environment, web scraping tool. So this was actually one of the first, first projects that I worked on with web scraping. So kind of unfamiliar with some things. The API underneath the site, there wasn't a publicly available API that the Food and Nutrition Service released to, hook into, so to speak. Maybe there is if there's some other way to find it, but there was nothing I could find that was kind of publicly available documentation for an API.
Cool. And then just one last question from Wes. He said, did you check the Aunt Bertha web since the aggregate programs?
What does that mean?
I'm not sure.
Oh,
maybe.
I don't know if yeah, so Aunt Bertha aggregates all.
It's breaking up there, but yeah, there might be a connection issue to Wes there. These are next
okay, I'm looking at Aunt Bertha now, and it seems like it's an aggregate of, it's a way to find help. So it's a social care network to connect people with social services, and they build tools. I did not check with Aunt Bertha, but that seems like a really great resource. I think that there is, this project was mainly focused on the policy piece. And so there's a lot of organizations such as Feeding America and others that are really the boots on the ground. They connect people to the actual resources, whether it's a food pantry or a congregate feeding area or a place where they can pick up meals. So there's a lot of these resources that people can use to actually get help that they need. Our work was more focused on the policy end. So, no reasonable person who's food insecure is going to look at our data set or try to figure out, anything about what we did, but it is helpful for the people designing the programs. But it does look like Aunt Bertha might be a really cool organization, and it seems like they might also build tools to help for these kind of missions. So thank you for that suggestion, Wes. Aggregates nonprofit programs like this. Okay, yeah, I'll definitely look into it more, Wes. Thank you.
Yeah, we scraped those guys pretty heavily. It was really good data.
Very cool. Yeah, I never heard of them. So, but yeah, thank you everyone for coming to the talk. And you can email me if you have any questions, and you can find my email on my website, nikkitadamonte.com.
Great, thanks, Nikki. And then on that, Wes, you're our next speaker. So if you want to introduce yourself there, you can then present yourself there.
Okay, great. So yeah, I'll just go ahead and stand up my pre-recorded and cross my fingers that our internet connection holds stable. So just a quick intro. I'm Wes Shepherd, CEO of Unified Insights. I figured, my talk might be fairly topical and a little more unique on kind of the back end of what you do with scrape data. So I thought we'd highlight what we've been building and in our approaches to data quality and structuring web data after it's pulled from the web. So without further ado, I'm going to go ahead and share my screen. And just let me know if it's showing.
Yeah, we can see your
okay.
PowerPoint.
So put it in present, and here we go.
Hello, my name is Wes Shepherd. I'm CEO of Unified Insights. I'm here today to talk to you about product data matching and categorization of web data on behalf of Scraping Hub and their conference here. Now, this isn't my first rodeo with web data. My last company, Channel IQ, was responsible for scraping about 3,000 retail sites globally on behalf of 300 manufacturing clients. We provided them pricing intelligence and brand intelligence on a daily basis. And it's really from this experience that I gained an appreciation for the complexity of integrating and cleansing web data. From that, I decided to start Unified Insights after we sold the company to really attack the data quality challenges of web data and other unstructured data sources. Now, given that this is a virtual conference, I've put my email and my phone number up here. Feel free to contact me if you have any questions. And I'll have the contact detail actually on the last slide as well when we finish for Q&A. Now, really the question is, how did we all get here and run into, I'd say, probably one of the bigger technical challenges of our lives? And for me, it was really, I think, the dream of being able to go after all of these amazing insights that you could get from web data. And principally from my experience, it was really going after like competitive intelligence, being able to kind of categorize just vast volumes of product data out there, tracking retail sales activity. But as we grew our company and as we've grown our new company, we've really realized just there's limitless types of use cases. And increasingly, not just business intelligence, but now artificial intelligence use cases. So there's really no shortage, and therefore, I mean, everybody is going after it. But again, we're going to talk about, some of the challenges and how we've been surmounting that. So we all got into this with the dream of pulling data from the web and showing these amazing insights. And it all seemed so easy, right? When we started looking at, hey, we can just go grab this web page, pull out this data, we'll drop it into some data visualization solution, get these great dashboards, and away we go. And then we found out it wasn't so easy. The reality is, when we're going after web data, if we don't really understand all the steps and procedures to handling that and structuring it before we hand it off to an end consumer of our information, the reality is we've built a house on sand. And I've often referred to it as that because that's what it feels like, is a big old pile of sand when you first start these projects. And so as we're kind of going through this, think about where you lie on that spectrum. I'm sure some of you have incredibly good processes, and some of you might be in the middle there. But we're going to step through some of the steps that we go through to kind of bring you to how do we achieve kind of a bedrock solution. So when it comes to data quality, 96% of companies cite data quality challenges as a major obstacle towards success with producing data to train AI models or producing data for analytics or BI initiatives. Typically, with web scraping, I would say that that's probably even worse because in many cases they're not working with web scraping. They're working with a lot of internal data sets. For the people with web scraping, I'd say it's 100%. Some figure it out, some don't. But when we've seen people implementing traditional data preparation and data quality solutions off the shelf, they run into some pretty big roadblocks. And that's because they don't focus on unstructured data. So tools like Alteryx, Trifacta, for example, or MDM products from IBM or Informatica are really, really built to handle your more traditional enterprise type of data sets. So web data really throws a curveball at those systems. Secondly, they're just not affordable in many cases. The last point is they don't focus on humans in the loop. And for anybody that's working with web data, I think one of the big wake-up calls is the amount of effort it takes to review this data with a human eye, with an expert eye, to try to translate it, categorizing or trying to figure out a typo or things like that. The last point I'd like to get to is really about web data integration drivers. So, I mean, what are kind of the key facts around it that are driving a need for data unification? So we've always seen web data integration vastly different, as I mentioned before, given the unstructured nature. It's also growing incredibly fast. So staying on top of it is harder than anything you can imagine. The 4 points I'd like to quickly make, though, that I think kind of make up the foundational challenge, right, are that each data source adds to the data heterogeneity, and that increases complexity dramatically as opposed to structured data. Second, you're generally cobbling together a lot of solutions, and there's a lot more custom codes. The amount of development and thought that goes into kind of a pipeline to process this data and catalog it is much harder. Third, continuous monitoring of the data is really the Achilles heel of the industry. To me, that's probably the most frustrating that I've experienced, is just staying on top of the changes. And then last, as I mentioned earlier, with the humans in the loop, you know, just figuring out a way to get them in and on top of these different workflows, capturing these changes in data, and making sure that you don't put out an inferior data product or insight is a huge, huge challenge. So at a certain point, we hit scale issues, either with the variety of data or the volume of data, and it's no longer an effective practice just to throw bodies at this and keep developing. We have to start taking machine learning into account and see how we can apply that. So as we think about how to use machine learning with web data, specifically how to really get at these endpoints and being able to match records effectively and categorize them effectively, we've got 4 key components of a solution. We've got your traditional data preparation, the stage that comes after the data has been extracted. There's another stage many people don't use but should use if possible, which really involves attribute extraction and harmonization of those attributes. As we clean up and kind of normalize and harmonize our data, it really makes machine learning sing and become much more effective and frankly be even usable in scenarios like this. And then the last 2, which I'm focusing on today, of course, really are the categorization and matching processes. You know, and if that weren't enough, you've got to kind of piece this all together into a workflow so people can get at it and do their various tasks. So speaking of workflows, the way that we put it together is that we start by taking all of this unstructured data, be it web data, relational databases, Excel spreadsheets, doesn't really matter. But we pull all this in and unify it in an ETL-like manner and do our data preparation. And then secondly, we start to harmonize our data. And it's really at this second stage of data quality that's super important, because it starts to feed into kind of how you're going to leverage machine learning. If you put more upfront work into cleaning your data, harmonizing the attributes, starting to define it and structure it better, it means the machine learning downstream does a lot less work. You spend less time training it. You spend a lot more time building up and scaling. So here we can extract and match attributes using natural language processing and what we call data dictionaries. And I'll get into that later. Third stage is really mastering the entities And then once we've really cataloged all our entities, again, it could be anything, but in our use cases, mainly we'll focus on product. We'll tie all those together, and then we can categorize them and structure them any way we want before we send it downstream to a business intelligence system, or a data visualization tool like Tableau. So from here, I'll give some visual examples of matching and categorization and how we approach these problems to give a lot more context. So speaking of the different variety of data extracts that we could be pulling from different sites, this tends to be one of my favorite examples, and probably the hardest thing for people to deal with, given that it involves schema normalization and then attribute harmonization, as I mentioned earlier. But it's easier to give in a context such as this. So if we're pulling data from one retail site, let's say, we got title, price, retailer, stocking status, some attribute. And then we get another website pulled in, and the schemas are different. Somehow we've got to kind of consolidate all of this into one master view. But there's two problems, as I mentioned: the schema and normalizing that, and then the attributes. So how do we go about doing that when we've got things like space gray as a color captured inside of a title, right? Well, we've got to extract that somehow and then get it into a target column for a consolidated record, for example. But not only do we have space gray, but in the other record, it's spelled G-R-E-Y instead of G-R-A-Y. So somehow we also have to build some type of synonym structure to then master these attributes. And that's where we've spent a lot of time trying to figure that out. And some of the larger guys out there, like Walmart, have them as well. But this really will bring you more than half the way if you can start to solve this problem, because then matching records and categorizing records gets a heck of a lot easier. So as an example, what we call entity extraction, we provide WYSIWYG interfaces, and then we have machine learning that'll kind of auto-generate dictionaries on a certain kind of context, whether it be like cell phones or clothing or shoes, to try to rapidly assimilate this unstructured data and then structure it into things like brands, model, sizes, colors. And as I mentioned before, it gets to be really important because you can't feed data like this into a machine learning model and expect good results. It's not going to match or categorize very well at all. You could spend days and days training a model. It won't work. But if you can start to extract and consolidate this data into one specific thing, so like in here you'll see with models, we've got different languages and different spellings all equating a single model, like an iPhone, for example, and a single color, a single memory. So first stage we call entity data and getting the attributes out. So once we've extracted words like gold or good or gray with an A or gray with an E, as I mentioned earlier, we're trying to get that to kind of one version of the truth. So in this screen, you can see over on the right, we have a master attribute of gold. And then we have all the different ways in which people are in the title field are describing gold that we can use as synonyms to structure. And really where this gets valuable is when it comes to the machine learning model. So when we didn't clean up the attributes and we just use things like titles and so again, semi-structured data, unstructured description fields, maybe a few varied attributes here and there, we'd spend days trying to train up a model to categorize or match our product data. Once we applied this process, and we might have spent maybe 4 to 8 hours building the dictionary for a large kind of category of products, What happened after that was that we only spent maybe 30 minutes training the model. And instead of getting 80 or 85% accuracy, we got 95, 96, 97, even 98% accuracy, which was within the realm of quality that we can actually use it. And so again, that's why, as I earlier said, it's just worth putting in the time up front. So then we get to our favorite part of matching the records. What we did to kind of make it easier for the people that would be kind of turking on this, and again, we built it more so for people, internal experts, or people with at least a little bit of training, so that they could attack kind of an area that they know, and they could build a WYSIWYG interface, kind of configure their matching process. All of this is codeless, so they can lay it out the way they want and sit there and match up the records. I think it's really important to provide, a highly intuitive, highly configurable interface to really capture the knowledge of your internal experts or, external. And then I think the other key component, again, this is just another approach to kind of how you can match records, is we made it quite easy for people to kind of configure fuzzy matching. And as you'll see, we've got columns of brand, color, memory, models, things like that have been harmonized. And so it makes it a lot easier, obviously, to determine whether a product is matching or not. If we had gone off the title alone, that would have been a disaster. And so generally our matching efficiency is going up by 2 or 3 times. And obviously, when you're paying people by the hour, there's a big scaling issue there to bringing on new data and new clients. And really, I think the last step, and this is the one a lot of people have trouble with, a lot of solutions don't provide, is what do I do when I've matched all of my records? Let's say I found 100 versions of an iPhone, or 50 versions of a Nike shoe. How do I consolidate that data without having to kind of go and scan the data manually, pick up the different attributes and build that one perfect version of the truth? But record consolidation is really key. And so even at kind of the lowest level, the way we view it is, we want to allow the person to kind of pick the most common attributes, or the ones from the best source, so they can quickly build these up. But once you've consolidated that master record out of thin air, that allows you to get much better matching from new records that are coming into the system, because you may have 20 attributes that kind of cover the span of possible attributes from anything from the web. Once we've matched our products, then it comes to the point where we want to structure. We want to add additional structure to these things. In this case, I'm just showing you an example of hundreds of ladders and categorizing these ladders from an MRO example. And so in our application, we take a fairly pragmatic view of machine learning. Obviously, we have the models. They make suggestions. People can agree and disagree, and obviously that continues to reinforce the training. But more importantly, to kind of the right of the suggestions on labels, we allow people to place rules in, either individually or in bulk. And it's really the combination of rules with machine learning that allows people to get near perfection, or perfection if they want, in terms of categorizing data. As good as we can get a categorical machine learning model, let's say 98, 99%, some people aren't even going to really want to put in the amount of work required, or that's not good enough. And so you can overlay rules in the areas where it's weak. You can strengthen it with rules. And to me, this is really the only practical way of categorizing data, web data, just because it is pretty slippery. So basically, users will come in, they'll accept a recommendation from the machine learning, or they'll reject it. they're assigned tasks to review it. They can add comments and so other users can see what they're thinking. But there's a whole workflow tied to this, and and everything else. So at the end of all these tasks, then the really big piece comes in, and that's how do you coordinate people? How do you coordinate the activity? Not only the labeling and the training, but approval cycles. How do supervisors actually go through and view this? And so, from our perspective, as you add more data, you add more people, you just generally get a lot more confusion. So it's imperative that we have ways of tracking people's activity, whether they're completing assignments, how quickly they complete assignments, what's the velocity of their work, what's the quality of their work. The other piece is allowing people to go in and out of different projects and different workflow steps, and really giving them the exceptions to manage that. Secondly is communication. Slack-like communication, so you can drill down to specific records where there's questions or concerns, and allow for people to interact. So with all of that, then you really get to the point where you can build a large-scale data catalog based largely on web data, and then you're ready to publish or monetize that web data at scale. I appreciate your time, and I'm happy to open it up for any questions. Again, my contact information is provided as well, so if anybody wants to reach out afterwards, you're welcome to do so. I know we've probably only got 7 or 8 minutes here for Q&A, so don't hesitate at all to reach out. And thanks again.
Thanks a million, Wes. That was definitely interesting to see the different techniques. So I think we have a couple of questions. I just had a couple of quick ones. At what point do you kind of see people needing machine learning or systems like yours?
Typically, I would say, with matching and categorization workflows like product monitoring, it seems to kick in, 100, 200,000 products or more. Generally, it also kind of factors into targets because you have the variety issue. So it's really, think of it as XY axes, variety and volume. You start getting into a few dozen sites and hundreds of thousands of records, and you're starting to throw a lot of bodies at it. And that's where this could really kick in. But I mean, we've run it at much larger scale, and I'm working with folks that are doing hundreds of millions of products.
Yeah, I was going to say
how men on about 100 people mechanically turking on one project.
Cool. Yeah, I was going to say how scalable is it?
Infinitely, really. We built the system on Elasticsearch, so it's just really a matter of throwing more, more memory and more cores at it to scale it out.
Cool. Okay, so there is a couple of questions in the Q&A panel. I'm not sure if you can see them, but I can read them out anyways.
Sure.
One says, do you unify data all in a data warehouse type architecture, or do you use federation/visualization approaches across RDBMS and say data lakes to be able to resolve entities across structured and unstructured data sets?
Okay, that's a mouthful. Hold on.
It's quite a big one. I don't know.
Okay, I see it from one.
Yeah, it's got a couple of votes as well.
So, I mean, we're principally using Elastic, and what we do. I'm happy to talk about kind of how we architect the data, but because we can do kind of infinite tasks or projects. So we'll spin up a task project, let's say for a classification model, and we can plug into an AutoML model on SageMaker, or we can plug into a custom model in Jupyter. It doesn't matter, but we principally use Amazon to kind of scale out our AI piece. But with the way we store data, it's very much like an ETL tool. Data comes in, we do the data prep, and then we unify it into like one catalog, and then each kind of model where we're putting people on for training, and iterating that model kind of has its own federation, I guess you could say, of data, where we have like child elastic docs tied to the parent. So we can essentially kind of pivot. We could have 10 different categorization models on the same data. We could have different matching logic on the same data. So we definitely built so we could kind of slice and dice the data in Elastic. But at that point, that's really kind of where we stop, and we'll ship the data out however someone wants it. And then they can take it downstream to whatever data warehouse or BI system they have. We really don't do ETL or web scraping, and we don't do visualization. We really try to stay in the middle where data quality matters. And I don't know if I got all of that question, but in fact, Juan has another question, time of ingestion. Yeah, so a question being, do you approach machine or do you approach matching based on time of ingestion, or does the underlying model allow for it to effectively relearn? And if so, does it reassert previously made assertions? So we basically allow people to retrain the models as new information comes in. We allow them to actually remove past information that may actually be affecting the model in negative ways. I think you're kind of getting at some of the issues that come up as you're iterating models, and sometimes you can build on bad training. So what we do is we build conflict. We show the conflicts between what users label and what the machine learning predicts, and we show those exceptions so the users can go in and, let's say if there are labels that are causing issues with the machine learning, they can remove that and take it out of the training, for example, and kind of optimize the training. But pragmatically, as I said in the presentation, there's really no perfect approach. Like you just can't rely on machine learning alone for the kind of quality that we're typically looking for. So what we do, we add in this other dimension where you can just lay in rules on top of those weak signals or those areas where machine learning just isn't able to kind of to fix it. And I've got one more. So if you don't have enough information about a product to perform a matching via machine learning techniques, would a human tackle these? Yes, that's exactly the whole point of injecting humans in is, the whole point is to know how confident the machine learning is. So if it's 95% confident, great. So for instance, we'll set thresholds, and if the machine learning is 95% confident, let's say we'll automatically take a match. If it's really not, if it's got kind of a weak confidence, maybe we do a bulk review. We still think they're matches. And then let's say anything below 70%, it's unlikely, and we put that into a deeper review where people are going to label it anyways. And it's important that they do, because where the machine learning's weak, you need the human reviewing it and labeling it to improve the overall training. How suitable? Okay, how suitable is this type of data ingest harmonized records for building knowledge graphs? Okay, that might be the best question. So when we really started this whole project, it was coming on the heels of a pretty sizable data company I had built, and I spent millions trying to figure out how to build a large-scale data aggregation system that was going to behave more like a knowledge graph. It just, I didn't know to call it a knowledge graph, back then. And so I really saw things as individual entities, customers, products, store locations, people. And what we're finding now in the market is people come to us and say, hey, what I really want to do is I want to link all this stuff up, and I want to be able to just, if I fancy enriching data from here, and there, I want it all linked. I want all these entities links, like one big, beautiful relational database. And what they're really asking for are knowledge graphs. So we're targeting 2021 to actually build in a reconciliation function. So when they're bringing in the data, we'll kind of auto-recognize it, connect the entities, and allow them to kind of better master the data before we kind of bring it into a unified set, but also allow people to bring in any type of data and kind of tether it. So if they want to add store locations to their products, they can do that. If they want to add customers. And so we're looking at a number of knowledge graph options out there. And more than likely, I think we're going to use Elastic as the index because basically graphs don't really scale well in certain ways, especially with search. And so we actually got lucky in that I think we picked the right architecture for search, and we can stuff a knowledge graph into Elasticsearch and be able to do the categorization and matching for a graph and structure it. So it's actually not too difficult. We started moving in that direction, and we're pretty excited about it. Let's see, is it a problem to introduce new types of products for product matching problem? You've shown a case for smartphones whose features are brand memory, inches, etc. But what if we introduce a new type of product defined by different features, for example, a traditional TV, which still has inches but not memory? Actually, maybe this one's an easier one to even just show an example. But we're agnostic, and the whole approach that we've always taken is allowing for people to create kind of different things. So for example, I've got a bunch of cosmetics data here, and this is my machine learning accuracy. Here are my exceptions that I'm going to need to work through. But to your question, how do we handle for different product types? So basically, we just use WYSIWYG tools to kind of build the schema for the new type of entity. And in this case, if it's cosmetics, great. And what we can do is we just build a task model. We pick a catalog of data, the table, which would be the schema for the different product type, whether it's matching or categorization. And in this case, I have to pick a taxonomy. But to your point, if to categorize, for example, what I really need is the retailer category, the retail product name, and the retailer brand, and then I can kind of configure my logic. Like maybe I want to kind of boost the product name, and I've obviously I've used a built-in analyzer in Elastic. But we can basically build these things, pretty flexibly. And in this case, and this is a test environment, I've got like 6 different versions of categorization. I've got some test data here, 5 different versions of matching. So in the same way, the matching is very similar. So I built exact matching, fuzzy matching. I can use fingerprint, which is actually really good for web titles. That's probably one of the best matching approaches I've ever run across. Hopefully that kind of answers it. But I mean, we don't just do product data. We can pretty much do any entity type, but we do really well on product data and any type.
Great. Yep, I think that covers it.
Awesome.
Is there any other questions anyone might have? That's all the open questions anyways.
Awesome. Well, if anybody has any questions, I shared my contact info.
Exactly. Yep.
Yeah, happy. I love to geek out on this stuff. So everybody's welcome to ping me and call. I don't care.
No problem.
Awesome.
So
Thanks, guys.
we'll share your details with everyone, don't worry.
Okay, cool.
Great. So that's the end of our talks on track 2. Sorry, just 1 second.
There we go. Yep.
Yeah. So that's it for track 2. Thanks to all the speakers who were on today. They were fantastic, definitely very interesting talks. And we will be providing the recordings for all these talks in the next day or so. But the event isn't over yet. There is still lots happening on track 1. At the moment, I think they're in the middle of a legal panel, a live legal panel, which is quite interesting. So I've put the link to track 1 in the chat, so I recommend jumping over there to catch that. They will be having a break at the top of the hour, but they'll be back 30 minutes after that for a couple of more talks on AI autocrawling and WebBoat. So it's definitely worth sticking around for. There will also be a competitions as well for some randomly picked winner for Boss headphones, Qualera discounts, learning credits, and stuff like that. So, yep, still lots to do. So I recommend jumping over to track 1 for now. Thanks, everybody.